So, warm welcome to all attendees, esteemed judges, top teams, as well as those who are watching this on our YouTube channel. This is Akshay Bhat, Science and Technology Specialist, who will be co hosting this demo day for track one of a Smart Protein Innovation Challenge 2021 with Devika, our Innovation Associate. So, the Good Food Institute is a part of a global network of nonprofits focused on accelerating the smart protein sector across business, science, and policy. So, the main goal of our organization is to basically drive the shift towards a sustainable and just food system through three segments of our work: science and technology, corporate engagement, and policy. Through science and technology, we build a very deep technology ecosystem which is necessary for the smart protein sector to grow, engage and influence scientists, researchers across academic institutions and corporates, as well as deep tech founders to step into this exciting space. So we drive industrial engagement with our innovation slash corporate teams to familiarize them with the sector and showcase opportunities on how their overall capacity could be game changers for the sunrise sector. So we complement these two areas with policy, whereas policy specialists initiate dialogues and engage and build relationships with regulatory as well as policy agencies across the world to create a conducive as well as fair regulation for the smart protein ecosystem of the sector, and also channel funds into R&D. So our international affiliates are spread across the United States, Brazil, Europe, Israel, Singapore, and Asia Pacific, specifically covering geographies and markets across the world with a functional strength of more than 150 staff members. And we all work with a single mission, single goal of making alternative proteins a viable and sustainable reality. So I think this we have reiterated several times as our global population continues to rise and is well on the way to reach 10 billion by 2050. I think the biggest question facing humanity at this point in time is how will we produce enough protein or enough quantities of food to feed such a humongous population. So the Smart Protein Innovation Challenge 2021 solicited solutions on the best possible ways of producing proteins through three main pillars. That is, through alternative proteins, through three main segments. That is, fermentation, plant-based, as well as cultivated meat, and the best possible ways of producing proteins to produce basically 3 square meals per day for the 10 billion population, which we foresee in the near future. So track one, we had basically two tracks, that is track one and track two. The track one was focused on education and ideation, where individuals dive deep into science, business, and policy of smart proteins, participate in the program to form cutting edge. Whereas track two was basically focused on enterprise creation, where teams participate in the program to form cutting edge startups and their own ventures. So we opened the applications exactly 7 months ago on the 11th of August and structured a program to initially prime participants in phase one through our flagship Smart Protein Digital Lab in the induction phase, that is basically phase one, by giving shortlisted participants access to materials on science, technology, and business, and which also include access to, let's say, educational videos, podcasts, panel discussions, startup manual, and so much more. And this was followed by a quiz assessment through which shortlist participants moved into phase two. So immediately after phase one, we followed with a matchmaking week where participants could explore synergies, find commonalities in, say, various verticals, align their vision and goals to form teams, which would then ideate in phase two to come up with a short proposal based on that idea. Phase three solicited a solid, in-depth proposal where teams covered product, process design, description, scientific rigor, due diligence to the best possible extent from their end, value proposition, novelty, economic and commercial feasibility, business model, IP, and commercialization strategy. During phase two, three, and four, we provided support through inspirational webinars, one-on-one support to shortlisted teams covering technical and business areas of smart proteins, opportunities to collaborate with the community, and access mentorship from world-leading experts to bring transformative alternative protein ideas to life. Finally, in phase four, after gaining valuable insights from leading industry experts to strengthen value proposition, build their pitching skills. Today, we are culminating ISPIC 2021 with a very much awaited demo day, the day where many of the teams will be given a chance to transform their ideas into reality. So the first iteration of ISPIC 2020, that basically the first iteration of the Smart Protein Innovation Challenge was in 2020, which started off with a highly intense outreach. We began our journey by onboarding smart protein ambassadors who we cherry-picked from several hundreds of applicants, and they in turn obviously did a very spectacular job of reaching out to more than 4,000 plus schools, colleges, and institutions, accelerators, and 25,000 students, researchers, scientists to inform and encourage them to apply for this challenge, of which we have had like 1,350 plus registrations with a mix of applications from 150 cities and 250 universities. So this year, or let's say in 2021, it was nothing different. So we had 745 participants spanning 116 cities across 25 states from over 590 colleges, universities, and organizations across India for the Smart Protein Digital Lab that was basically for the phase one induction. There was a mix of 368 participants with bachelor's degrees, 146 master students, 11 PhD students, as well as 15 researchers, 86 entrepreneurs, and 112 other young professionals. So overall, 320 candidates have been certified from the world's first smart protein digital lab. Followed by this, a total of 96 teams formed during the matchmaking week in phase two. 53 teams comprising of 128 candidates participated in track one focused on scientific innovation. 33 teams comprising of 95 candidates participated in track two focused entrepreneurship. And we had a mix of 10 teams in cultivated, 21 teams in fermentation derived, and 68 teams in plant-based protein segments. After engaging with 40 inspirational webinars and mentoring sessions and I think hundreds of hours of worth of resources during phase two and phase three, the top 23 teams comprising of 60 individuals have qualified for phase four, that is initiation and demo day. So track one, specifically talking about track one or innovation track has a total of 11 teams, out of which 8 teams are focused on plant-based, 3 teams are focused on cultivated meat and fermentation, whereas track 2, which is focused on entrepreneurship as well as venture creation. 12 teams have been formed, out of which 5 teams have a plant-based focus and 7 teams are focused on either cultivated meat or fermentation. So over the course of the Smart Protein Innovation Challenge ISPIC 2021, we have had more than 40 mentors from academia, industry, and from our GFI Ideas India ecosystem who helped us in the challenge with knowledge webinars and mentoring sessions on various topics, ranging from financial modeling, IP strategy, to other various scientific and technical sessions across the three key platforms. We are always and will always be immensely grateful for the help, time, and efforts to make this initiative a great success. So our sessions are all open access and have been uploaded on YouTube. So to all participants today, please subscribe to our YouTube channel. We'd appreciate you if you could spread the word and about these inspirational webinars and in fact, actually truly make them inspirational, right? So as we envision, we continue to create several such iterations of ISPIC in the coming years and witness rapid advances of this sector in India. We would like to have more people on board on this exciting journey. A dream come true is when we are able to say that this is the best ever cohort for every single cohort, every single year for the next 10 years. And as in when the sector in India matures, as well as it matures globally. So like I said before, as we would continue to challenge ourselves to a secure, sustainable, as well as just food system. So please let your network know the importance of what we're trying to do, achieve for our current and future generations, both personally or through your social media such as LinkedIn, Facebook, Twitter, Instagram. As a team, we'll start charting out our next version of this challenge very soon. So moving on to our judges today. So we have 7 judges in total. We have Dr. Madhusudana Rao, who is the CEO of Atal Incubation Center, Center for Cellular and Molecular Biology, Hyderabad, with a PhD in biochemistry from the National Institute of Nutrition, India. He has extensive career experience in segments such as gene delivery and protein engineering with 12 US patents. At CSEMB, he has coordinated several multi-institutional projects such as with institutions such as Purdue University as well as Roswell Park Cancer Institute, and he's been a very, very important key stakeholder for GFI India since the past 2 or 3 years. So a warm welcome, Dr. Madhusudan Rao. Next, yeah. So next on, we have Mr. Rakesh Rajiv, who is the Senior Incubation Manager at Society for Innovation and Entrepreneurship, SIGN, IIT Bombay. He comes with 10 plus years of experience in technology incubation, marketing, business analysis, project management, and commercialization. And we have a startup which is in this segment of alternative proteins currently incubating at SIGN, IIT Bombay. So a warm welcome to you, Rajiv, as well.
Thank you.
We have Dr. Narayanan. Dr. Narayanan is a principal scientist at IIT Madras Bioincubator, where he provides consultancy and technical support to startups and connects them to strategic partners for technology development and transfer through rich and diverse network of the best and sorry, rich and diverse network from one of the best bio incubators in India. So a warm welcome to you, Dr. Narayanan. We have Dr. Ashutosh Upadhyay, who's a professor and HOD, Food Science and Technology Department at NIFTM. Dr. Upadhyay has more than a decade of experience in health, food safety, as well as minimal processing, not to mention a large number of publications as well as awards in his name. So warm welcome to you as well, Dr. Ashutosh. Next up, we have Dr. Gurmeet Singh. He's a professor and center head at Transdisciplinary University, Research and Development Transdisciplinary University. He has about 18 years of experience in research and development in FMCG industry, and he has invented, developed, and implemented new technologies to deliver novel and superior. We also have Dr. Idis from ETH Zurich, who's a postdoctoral scientist working with Professor Alexander Matthews at ETH Zurich. And Dr. Idis has a PhD in food science and technology from ETH Zurich, and her expertise lies in the area of microalgae and seaweed. So a warm welcome to you as well, Dr. Idis. Next up, we have Dr. Vasamon. Dr. Vasamon is a scientific specialist with GFI APAC, and her specialization lies in plant-based meat. She has a background in as a research scientist in plant bionutritionals and has worked at Abbott Laboratories for 8 years as a food scientist. So a warm welcome to you as well, Vasamon. And we are immensely grateful for all of you for taking out your valuable time for our demo day today. So last but not the least, a final and a very big shout out to our sponsors for enabling the prize pool, our title sponsor, Capri Global, our key sponsors, NICE and Alchem Foundation, and our partners, organizing partners, CIA, co-supporting partners, BIRAC, NIFTM, CCAMP, AICC, CMBIT, Madras, Bioincubator, Sign and Label, our ecosystem enabling partners, Blue Horizon, DSG, Fixie, Brink, Ankur Capital, Axelor Labs, ProVich, Omnivore, Agni, IMSA Ventures, Big Idea Ventures, and Huddle. So the success of this challenge would definitely not have been possible without the support of our sponsors as well as our organizing partners. So coming to what we are all here for, the much awaited pitches. So like I said before, we have 12 teams in track one across plant-based fermentation cultivated meat. And we'll start playing the pitches now. The pitch will be of an average of 6 minutes, like I said before again, followed by a Q&A session for a rapid fire question for 5 minutes. I request participants to keep their answers clear, terse, and to the point. Dear judges, please score the team against their respective name in the evaluation form, which we have supplied to you. So before we start with the first pitch, we can pause here for a moment, and if anyone has any questions, we can take it. So the first team to go is BioThrive. The technology focus area is plant-based meat. Their product is called as Oilsome. The tagline is best bite in your plant-based meat. So the primary member here is Preksha Nidhi Kohir, and other team members would be Prerna Balasubramanian and Samiksha Jayagatkar. Their introduction includes that their team is a trio of tech-savvy graduates. Prerna is a biotechnologist, Preksha is a food scientist, and Samiksha is a food technologist. And all of them together are passionate as a team and are looking to integrate science and sustainability in the smart protein landscape. So presenting to the judges, BioThrive.
Hi, we're Team BioThrive, and here is our pitch to bring out the best bite in your plant-based meat. We introduce Oilsome, a novel spin on vegan oils to bring lip-smacking goodness into the plant-based meat category. So what makes you love meat so much? Well, when I think of meat, I think about that mouth-coating richness, that juiciness, and the burst of flavor on that very first bite. Plant-based companies are on the rise as consumers accept a more flexitarian diet. However, a major barrier in smart protein meat is fat and moisture. Fat is an essential component as it improves the tenderness and overall palatability of the product, and moisture influences the texture and juiciness of meat alternatives. Since these are two key factors that play a role in the commercial success of plant-based meats, we have decided to tackle this problem. So what is the problem? The current gold standard of fat in commercial products is the pre-mixed emulsion made of water, a mix of coconut and sunflower oil, and synthetic emulsifiers. This solution faces several disadvantages. Firstly, in contrast to liquid vegetable oils, animal fats are solid and elastic at room temperature due to a high proportion of saturated fatty acids. They also have other disadvantages such as oil leaking onto the pan during cooking, high use of synthetic emulsifiers that has a concern with food safety laws, and low moisture content. So our aim of this project was to develop a solution that would alter the structure of oil, improve the stability of oil in the product, formulate a product using natural ingredients, and inclusion of both fat and moisture in our final product. Over to Preksha.
We are using a novel fat structuring based approach wherein we are converting liquid sunflower oil into a viscoelastic emulsion by altering both the water phase and oil phase using structuring agents. Therefore, we introduce to you our novel product Oilsome, which is an advanced emulgel that will help in incorporating fat and moisture. In brief, the emulgel is prepared by forming a hydrogel and dispersing it in an oleogel prepared using natural proteins and polysaccharides. Here we demonstrate the molecular structure of our emulgel. The hydrogel is prepared using pectin and water. The pectin forms a network, alters the water phase, and improves moisture when added to the product. The oleogel is made of pea protein and sunflower oil. The protein plays a dual role in the emulgel. It creates an interface between the two phases and helps in mimicking animal fat. Hence, by adding structuring agents to each phase, an emulgel with high stability is formed. In order to make the emulgel, firstly, a pea protein dispersion was made by mixing pea protein isolate in water. Next, the sunflower oil and rice bran wax was heated and blended thoroughly to ensure the incorporation of wax in the oil. To prepare the final emulsion, the pea protein dispersion was slowly added to the oil mixture and was subjected to homogenization to form the water in oil pea protein emulsion. Next, the pectin, which is dissolved in water, is added to the pea protein emulsion and was further homogenized and cooled to ensure the structuring agents stabilize the emulsion to form the oleogel. This gel is further subjected to dehydration to remove excess moisture and form the emulgel. The entire process requires only two equipments, one, the water purifier, and the homogenizer. Oilsome can be used in a variety of smart protein products like kebabs, sausages, and burger patties. The characteristic marbling effect can be achieved in whole cut meats by using our product via 3D printing. Over to Samiksha.
So, there's an ardent need in the plant-based meat sector for smart fats that behave like animal fats. Our competitors in this regard belong to both plant-based and precision fermentation areas. But this is where we stand out. Our product Oilsome is unique because it replicates properties of animal fat like similar melting point, semi-solid nature. It has a healthy unsaturated fatty acid profile since it's rich in oleic acid. The gel matrix altogether ensures stability of the product. Small amounts of our product goes a long way to improve the end product's organoleptic profile. Thus, unlike oil, our product does not leak onto the pan while cooking. The ingredients in our Oilsome are all regarded as GRAS, that is generally regarded as safe. This makes Oilsome clean label because it uses minimally processed and locally available ingredients. Oilsome has high potential to replace saturated and trans fat because it mimics the behavior of solid fat. This is our future business model in a nutshell. We would like to collaborate for R&D on fat encapsulation. We would adopt a B2B strategy where plant-based meat manufacturing companies in India will be our potential clients. Our product is priced at a nominal charge of rupees 200 per kg. This is our timeline showcasing our step-by-step plan for the next 2 years. We would require an overall funding of at least 60 lakhs to get started. Now, there might be challenges like phase inversion, which is basically a type of instability in emulsion. Now, this we will address by stability tests being done from time to time. Our future projects will include fortification of our product with nutrients, exploring its potential in eggs and seafood and other conventional foods as well, replacement of trans fat and saturated fats in food to reduce the total food calories and substitute it with healthier fats, hire a diverse team of scientists, sensory analysts, and advisors who would help us to improve our product. And finally, on behalf of my team, Prerna, Preksha, and myself, Samiksha, would like to say that it has been a great experience. We would love to thank the entire GFI India team and sponsors for this dynamic platform. Thank you so very much, and we would love to answer your questions.
Yeah, thank you, Team BioThrive. So we have promoted BioThrive team members as panelists. So judges, please feel free to shoot your questions.
Can I ask a question? Gurmeet here. I can't see the raise my hand sign on my computer for some reason. But anyways, my question is this, just trying to understand your product. Is this a ambient stable product that you are making? Or what temperature, what shelf stability are you targeting?
Akshay, want to take this?
Our preliminary research has suggested that this product is stable for a period of 6 months, and we are looking to incorporate this emulsion into our Indian plant-based meat products.
But your product is the emulsion, right? You're selling the emulsion in a bottle or something like.
Correct.
Yes, it's in a form of a gel. So basically, to just recap our solution, currently emulsifiers containing sunflower oil, water, and some synthetic emulsifier is used in plant-based products. But then we want to create an emulsion that is more stable, that can be used to replace these current products that are being used.
Yeah, no, that I understand. I was just trying to understand whether you're looking at a ambient stable product or a cool supply or a cold supply chain, or what are you targeting, and what kind of shelf life are you targeting when you're looking at stability? And stability, when you say that you have a stable product, it is physically stable, isn't the emulsion stable, or if you looked at rancidity and microbe and other stabilities as well?
Yeah, so we've looked at this as well. So when we compare it to similar products in the market, we find that they are stable for 6 months. So hence we have given this estimate. However, we have to conduct further studies of our own to see, what is the exact shelf life of our product. Coming to the rancidity part, when we see neutral oil, they have a shelf life of more than 6 months. So and when we see plant-based meat, they are stable for around 15 to 20 days. So when you do incorporate it into other products, it will hold the shelf life.
Yeah, thank you. I think we have a couple of other raised hands. So Dr. Narayanan, would you like to go next? Thank you, Dr. Gurmeet, for your questions.
Yes, sure. Thank you. Hello. Thanks for the nice presentation. I just have a couple of quick questions, one related to your experimental design, and the second one about your technical feasibility when you're going to scale up. It's a very nice strategy that you come up mixing the hydrogel and the oleogel, forming an emulsion. And you also highlighted that this phase dispersion and inversion are going to be critical points to be addressed there. Yes. But I wanted to know, or I was just thinking, when you compare the self-assembly process that sometimes happens versus the interfacial control, what you're going to implement, which you also highlighted in your presentation, there are some crucial parameters that need to be investigated, which will involve a lot of probing techniques, for example. And when I look into your timeline and the budget, unfortunately, these are not explicit. So my thought was whether you'll be outsourcing them or whether you have the infrastructure facility to handle this issue. And connected to this, the second question will be, you showed this and highlighted this as a simple experimental design. But when you're going to scale this up, the physics is going to become different, and so will be the properties of your product. So what are your reflections on this?
So can I take the first question? So coming to the timeline, so what we saw is small startups usually take around 1,000 trials to come up with their final product. So we have adopted a similar kind of timeline as startups. But what we want to do is we want to collaborate with innovation labs that already have the experiments and they already have the equipment with them. So if it's microscopes or anything that is needed to perform these experiments, especially the stability tests and the taste tests that are needed, the sensory analysis that is needed after making the emulsion, we would like to collaborate with innovation labs. So that's why our timeline will get reduced. We also saw the case study of AAK. So they're able to come up with products within 2 or 3 months because they have the capacity to do that. So collaborating with industries like that who already have a standing in this, fat encapsulation sector will be able to accelerate our timeline even more.
Yeah, thank you, Narayan, Dr. Narayan and Preksha for the Q&A. I think we are running over time. We can take one last question from Dr. Ashutosh, since he raised his hand first.
Thank you. So one quick question, because part of the question in terms of the timeline budget already had by Professor Narayanan. So my quick question is, means how do you visualize the challenges with the hydrogels? Means formation is possible, but bringing it to the product and then diffusion part of it and then sensory impact. So means do you have some understanding on emulsion making and making it for the product impregnation or diffusion part?
Believe in order to
continue please if you are clear about the question.
So we believe that further trials are needed, further research trials are needed, and I think that stability tests have to be done from time to time, like a centrifugation test, shear stress test. So that will tell us about whether our product is separated or not.
Just to add another point, there are already existing products in the market who have already done similar things. However, we're just trying to make our product even better by, going over the safety guidelines or making it suitable to the Indian market. So it's not like this product isn't possible at all because there are other companies who are working on this. There's a lot of research going on in this sector. So we believe that through collaboration, through learning, is how we would be able to get this product into the market.
Okay, one final shot. Means you haven't tried at all this, so only the conceptualize the idea, right?
Yeah, so track one was proof of concept, that's all.
That's it, okay, but it still means despite of it, because the team is the tech side, so technologically you have not experimented so far, fine.
Right.
Yeah, thank you, Dr. Ashutosh, and Team BioThrive, thank you for your answers. I think we can move to our next team now. The name of the next team is Ayuva. The technology area is fermentation derived protein and ingredients. Just a minute. So the product name is No Casein, and the tagline is the No Compromise Dairy. The primary member name is Shama Bhat. Shama is representing Iowa Labs, and they're working to be a part of the new Indian dairy revolution by developing bovine dairy proteins through precision fermentation. So Devika, if you could please go and play the pitch.
Hey, I am Shama Bhat of Team Yuva. Our goal is to develop a non-compromise alternative to protein derived from animal sources. Our end goal is to develop revolutionary manufacturing methods to produce animal-free casein protein. We have picked casein because it is widely used in many industries, but currently it can only be produced via extensive processing of bovine dairy. This levies a huge toll on environment and consumes a lot of energy. The dairy industry effluent pollutes the underwater reserves with nitrate. About 60% of Indians exhibit immunogenic reactions to animal dairy. Casein isolation is an energy-intensive process. 80% of Indians are protein deficient, despite India being the largest producer of dairy. There is a lack of vegan options which can be adopted without changing lifestyle. Not only are the animals treated inhumanly, but also excessive use of hormones and antibiotics impact health of the humans. Talking about the environmental impact, 1 kg of casein consumes 8,300 liters of water, 120 meters square of land, and emits nearly 40 kgs of carbon dioxide. By leveraging cellular agriculture, we are giving E-cells the instruction manual to produce casein proteins in the form of DNA. These brand new E-cells undergo fermentation in large bioreactors where they consume the nutrients to produce casein protein. This method is far more efficient as it emits 65% less carbon dioxide, needs 97% less land, and uses 99.6% less water. Even the protein consuming industry benefits as our animal free proteins can be used in vegan products with high profit margins. The sterile manufacturing methods minimizes bacterial contamination and reduces manufacturing steps with giving them insurance in the consistency and quality of protein yield. We want to start by developing A2 beta casein and then move on to the beta lactoglobulin, which is a whey protein. The development of rest of the proteins will be determined based on the necessity and functionality. This is a roadmap to POC. We have completed the ideation, literature review, and IBSC approval. We are currently working on developing expression system of A2 beta casein. We are expecting to establish our POC in the next 12 months. Is this work done before? Yes, all the dairy proteins have been expressed in either yeast cells, bacterial cells, or mammalian cells. Companies like Perfect Day, Remilk, Change Foods, Imagine Dairy are trying to develop dairy products using recombinantly produced bovine dairy proteins. There are patents related to this work from companies like Perfect Day, Bhat, and Unilever. Overall, Pichia pastoris makes a good host cell because of its ability to make post-translational modifications, multiple gene interaction, easy handling with low cost to give high protein yield. Also, since the protein is released to the growth media, the extraction of the protein is easier and cost effective. The expressed protein will be measured using different analytical methods like STS page, LCMS, Marlitov, etc. From our literature review, we are expecting a protein yield of 5 grams per liter with a gold standard of 10 grams per liter and protein purity of 90% with a gold standard of 99%. This is a brief representation of our work plan. We'll start by developing the construct which will be transferred to yeast host cells which are grown in the shake flask. Then we'll be working on the fermentation, protein purification, protein analytics and characterization. We will be carrying our R&D work in Bangalore Bioinnovation Center which has all the necessary equipments that we need. The key points to be considered in these projects are challenges with the host cell protein expression, post-translational modification, availability of infrastructure, global regulatory requirement, quality control, and quality assurance. We plan to tackle them by exploring different expression systems, stain improvement techniques, using CDMOs, regulatory consultants, and incorporating ISO and following the Alcoa principles for quality assurance. The alternative protein market is projected to grow with a rate of 14% every year and is expected to be $290 billion by 2035. The global casein market is $1.3 billion and the Indian casein market is $25 million. The serviceable obtainable market by us is $2.4 million. Our brilliant team is led by Dr. Jyoti Iyer, who has worked in Biocon for 17 years as the head of protein development. Dr. Vihan Galsasi brings with him a wealth of experience in molecular cloning from his tenure at Syngene, working on yeast expression system. I am trained as molecular biologist and have experience in developing microbial expression system. Saurabh Padi is experienced in project management and fundraising. He also looks at the business, marketing, and financial aspect of the company. We are mentored by Dr. Narendra Chirmule, who helps us with industrial networking, risk assessment, Mr. Ravindra Patel, who helps us with cell culture media, Dr. Narottam Acharya advises us on molecular cloning. We have also been awarded with Nidhi IR Fellowship, Startup India Seed Fund Grant, Nidhi Prayas, and have been shortlisted for the Pro-Veg Summer 2022 cohort. Thank you.
Yeah, thank you, Shama. And yeah, now the stage is open for Q&A. So judges, please. Yes, Madhuji, please go ahead.
So you are planning to express all the caseins or one of them?
So we are targeting the A2 beta casein and kappa casein first, And depending upon the functionality and requirement, then we will be looking at other casein proteins.
Okay. And you probably know that there are many players right now in the milk thing. So you're yet to start. So how do you look at your prospects?
So currently we are using a completely different host, and we are trying to work with CDMOs, and we are looking at, since we are located in India, it will be easier for us to scale up. And since we are at the early stage, we can easily pivot to different directions depending upon our protein yield. And being in India will help us to work with different CDMOs and in the manufacturing process, and hopefully get our protein to a relatable cost price.
See, you are also focusing only on casein. So how about other things? Because milk is a pretty complex stuff. So without other things, it's going to be it's a very partial milk in a way, if you ask me.
Yes.
So what is your plan?
We are starting with working on casein, but we are still planning to work with beta-lactoglobulin, which is a whey protein. And once we have all the proteins required, the casein proteins and whey proteins, and then our next step is to work on the fat part, and also the adding the vitamins and minerals, and then moving on to working on the milk composition part.
Okay. Thank you.
Thank you, Madhuji. Iris, you can go next.
Hello, thanks a lot for the pitch. I actually have 3 questions. One is related to the previous question too. So, the first question, what is your unique selling point? Because like it was mentioned before, there's already other industry and also other companies, I don't know, startups doing protein from yeast or from bacteria. So what would be your USP here?
Yes, so we are mainly focusing on A2 beta casein, which is comparatively has low immunogenic effects compared to other beta casein, which other variant of beta casein, which will contain A1 type of beta casein, which is known to cause immunogenic effects on humans. And other than that, we still believe that this market is growing to be big enough for multiple players to exist and still survive. And other than that, as I said, depending upon, since we're located in India, we are still looking at working with other CDMOs and working on our manufacturing and scale up plan based on that. Currently, our goal is to bringing up our protein yield as high as possible and reducing the cost price of the protein.
Okay, is there any benefit of the yeast strain that you are using? Like faster growth, higher protein yield also?
Yes. So there are a lot of reasons why we chose Pichia pastoris, since it has a less amount of endotoxins. So the proteins will be directly secreted into the growth media, and the protein, the Pichia pastoris is known to give a good amount of protein yield for heterologous protein expression. And also Pichia pastoris is widely used in pharmacological protein expression in India. And this is something which has been widely studied in India and has been used in India for more than a decade now. So this gives us a better opportunity to work with this hostels, since we have a lot of expertise of people who know the work in Pichia pastoris, and there are many CDMOs who just work on Pichia pastoris.
Okay, thanks a lot. There's only one second question that I will pose. How do you plan to do the scale up? Yes. Because now you proposed lab scale experiments, but how do you want to do the scale up? Do you want to do it via contract manufacturing, or you want to build up the scale up yourself, the industrial scale fermentation cultivation?
We will start our scaling up process working with other institutes like BBC. The Bangalore Bioinnovation Center has up to 10 liters of fermentation. So we'll do the pilot scaling up, and we still want to work with other CDMOs. We have already contacted Syngene and Anthem Bio to ask about their quotations to get an idea of the CDMO work, the fermentation outsourcing as a plan. And we also want to work on food-based fermentation CDMOs to take this protein for our scaling up plan.
Okay, great. Thanks a lot.
Yeah, thank you, Iris. We see 3 more hands raised. So I request judges to limit their question to one big question you want to ask. Thank you, in the interest of time. So I think we can go with Rakesh. Rakesh, if you want to ask a question.
Thanks. Hey, question I had is in terms of the economics. So that's one of the challenges in terms of artificial casein. Scaling up is slightly away, but have you guys thought in terms of the economies of how, the various ingredients that needs to be added, and how does it compare with how is it obtained naturally? Thank you.
So we have done some basic cost differences studies with the existing products right now, with the existing artificial casein, like synthetic casein itself, and also, but we look at our competitors as the organic milk or plant-based milk products out there. So when we look at them, we still can get a cost price to 800 kg per casein protein. So this is our target right now.
800
kg per 800 rupees per kg.
Okay. And how does it compare with what the current?
So the current market, which is the current artificial casein out there, it has a similar price range.
No, I'm saying the natural casein.
The natural casein has a very less price range depending upon the casein. But when we look at the purity and other related...
Comparable. How does it compare?
So currently the casein protein is about, depending upon the purity, the purest casein would come from 650 rupees per kg.
No, you compare your purity in terms of the purity which is available in the current form of doing it. If you compare apples to apples, how does it compare is my question.
Okay, so we were planning to develop a pure casein up to 99% pure casein. Currently, the casein purity is up to 86%.
Mm-hmm.
So that is the purest casein. So there are different grades of casein.
So yeah, what's the cost coming then? So for the 86% in the market currently.
Yes, even the cost price, it varies differently.
Roughly, I need a ballpark figure.
So the ballpark would be about 650 rupees. So it really varies from 650 to 700, 900 rupees.
Yeah, thank you, Rakesh. Dr. Gurmeet, would you like to go next?
Yeah, just wondering if you've got a chance to play with both the proteins. Did you get to handle, say, a milk protein casein and a expressed one, if you've managed to procure some and see how they're different?
Not right now. We've not started working on that, but we did get we did look into this quasi-bio, which has produced recombinant casein protein, but that is something that we are planning to procure for our later protein analytic stage. Yeah. Once we have our own expression, that is when we want to compare with the regular milk and the protein expressed, recombinantly expressed casein protein and our expressed protein.
Yeah. A good idea to just get some, I mean, a few grams just to play with, to see what, because that may throw up a lot of ideas as to what are the differences, what are the opportunities. So, yeah.
Yes, definitely.
Okay.
Yeah, thank you. Sorry, Dr. Ashutosh, in the interest of time, I think we should go to the next.
Yeah, pass, not necessarily. Yeah, that's it. Done.
Yeah, thank you. And if any judges have any additional questions, we can take it offline and you can send your questions to the participating teams as well. So if you can write it down, then we would appreciate it. Yeah, like 10 seconds to put in your scores and we'll move to the next pitch. Great. So moving to team 3, the team name is Millbiotics. The technology area is plant-based dairy, and the product name is also Millbiotics. So the tagline is "Be traditional, healthy, millet and almond-based curd containing unique probiotic culture, along with various phytochemicals." The primary member's name is Pintu Chowdhury, and the other team member names are Bhosale Yuvraj, Akshay Rao, Mayur Kadam. And a short introduction would be basically they have put the introduction as their qualification. So I think we can just move ahead with the pitch, Devika. Thank you.
Hi everyone, this is Team Millbiotics. I am going to share a journey about millet-based product, which is very unique in its ingredient, its nutritional value, and its microbial culture. Here is Team Millbiotics, myself Dr. Pintu Chowdhury, accompanied by Dr. Yuvraj Bhosale and Engineer Mayur Kadam. India is leading in livestock population, which provide a sufficient amount of milk, but also contribute toward the production of greenhouse gases. The production of curd follows same fate as milk. The per capita consumption of curd is around 3000 gram per person, expected to grow at the rate of 15.3%. However, there are limited plant-based alternatives. Though consumption is very high, there are certain limitations associated with dairy curds. There are ample of manufacture of non-dairy fermented products, but their main focus is on yogurt. A couple of plant-based curd are available, but that are costly. This is our journey where we have started right from problem identification, progresses from ingredient selection, strain identification, product optimization to the present day. Here is the solution. As ingredient we have selected indigenous crops such as kodo millet and almond for their respective benefits. Why millet almond combination? It is lactose free, it is gluten free, it is nutrient dense due to high content of protein and fiber. It combined various phytochemicals. Together all nutrients interact and improve digestibility and provide various health benefits such as reducing risk of cardiovascular diseases. Now I would like to call Dr. Yuvraj for taking over the presentation.
Thank you, Pintu. The selected ingredients such as kodo millet and almond were soaked separately and then pulverized into colloidal ball meal and homogenized further in order to get the homogenized whole milk. Considering conventional milk fermentation, lactose in presence of lactic acid bacteria is converted to glucose followed by pyruvate and lactic acid. But for the polysaccharides such as starch, it first needs to be converted to glucose with the help of alpha amylase, which subsequently converted to pyruvate and lactic acid. To facilitate the fermentation of polysaccharide, the chili stalk was selected, which is a polysaccharide based material. From this chili stalk, the microbes were inoculated. Further, these microbes of interest were selected based on colony morphology and characters. These microbes were then pure cultured and analyzed through biochemical tests. Further, confirmed with RT-PCR tests as a lactic acid bacteria. These lactic acid bacteria were then inoculated into milk to ferment in the form of curd. The nutritional composition of optimized curd revealed comparable amount of protein content, superior fiber content, and lower amount of fat content compared to conventional dairy curd. There are several phytochemicals that are adding value to developed product. Total phenol and flavonoid represent a group of biologically active secondary metabolites which are observed into considerable amount. These secondary metabolites also contribute towards the higher antioxidant activity of developed curd. To mention specially, a good amount of GABA content was observed into developed curd, which is popularly known for its antihypertensive activity. Apart from that, a good amount of minerals, mainly iron, calcium and zinc, was observed into developed product, which are playing a vital role in regulating various biochemical processes. In other quality analysis, the developed plant-based curd was comparable with conventional dairy curd in terms of textural, rheological and organoleptic properties. Apart from that, a good number of viable cell count was observed into developed curd which will be acting as potential probiotic. Currently, we are looking forward to analyze the feasibility of isolated microbial strain for other ingredients, which will be helpful for increasing the range and diversity of our products. Moreover, we are in process to get the IP rights for the same and proceed with a startup. So currently, these are the lab scale equipments which are available with us, which will be used for the process optimization for other ingredients. These are the funding agencies that we are going to target. For research, MOFPI, SERB, DBT, ICR and CDB are under our main focus. For commercialization, our targeted schemes such as PMFME from MOFPI, NABARD and BIRAC. On behalf of my team, I would like to acknowledge the technical support from Mr. Aniket Pathare. Also, I would like to thank GFI India in order to provide enormous support throughout this competition. Also, I would like to thank NIFTEM Tanjavur for providing the facility to complete this work.
Yeah, thank you, Millbiotics. Now we'll open the stage for questions. Madhuji, you have raised your hand, so please go ahead. Just a minute, I think I've not promoted the team. Just give me a moment.
Shall I? Hello.
Yeah, sorry, Madhuji, just give me a moment. I'll just promote the team member as a panelist. Otherwise, he or she will not be able to hear your question.
Each time, right? I mean, I have to buy the curd each time, right? I cannot, like what we do at home. I mean, I can use the previous curd to make my own curd next day. That's not the plan here, right?
So basically, we are having once we have isolated culture, so we can use that for further preparation. So, like traditional curd, we can use it, sir. It's possible.
At home?
Yeah, sir. But storage conditions should be hermetically means isolated conditions should be there. Otherwise, there will be chances of contamination.
Yeah, drifting. Yeah. Okay.
Dr. Gurmeet, please go ahead.
Yeah, I could not understand your product exactly. Like, how are you expecting the consumer to buy the product and use the product or reuse? And what is the business? What's the business model? What's the pricing? How does it compare with anything else I buy? I could not get a sense of the product part of it. Yeah.
You guys, please take the question. You guys like to take the question?
Hello. Yes. So the plan is like how now recently conventional dairies are there. They are selling their product when we are considering the curd, right? So we are planning the same way, like by isolating specific microorganisms to ferment the whatever curd, whatever milk we have developed. So that will be packed in commercial packets of like 200 ml or that much quantity, and then it will be sold in the market.
So it's a curd that I'm buying, which has some functionalities.
Yes, exactly.
And I buy it only once, and then I can reculture it at home. So what's the business model, that I buy it every time, or?
No, every time you need to buy the curd packet.
Okay, and how would it compare? You're pitching it at a premium to normal curds, or?
Yeah, generally whatever plant-based curds are there, like due to lactose intolerance, and also people are preferring plant-based curd nowadays. So we will be playing a role. Nowadays yogurts are there more in market. However, nobody or couple of players are there for curd selling, but they are costly. So in order to tackle this problem, we have selected the indigenous ingredients which are quite cheap, and from that we have made this curd, and we have isolated a microbial strain which will be helpful for fermenting this curd and giving you proper structure and other properties to this curd.
And what kind of budget are you looking for to get to? What's the next stage that you want to get to?
Yes, initially we will be expecting around 30 lakhs for conducting trial on other ingredients, because now we have tried on kodo millet and almond, so results are good. Okay, so based on that, we'll be trying for other ingredients, like for looking for cost economic things. So after assessing the feasibility, we'll be going for like initially we have a facility for production, but that is like third party based. But when
what
we want
I'm not
to
able to understand is why look for new products if you have something. You said because of cost. Then what we are not getting a sense of from your presentation is, what is it you want to tackle? What technical challenge or what unlock that you're looking for to get to the next stage?
Yeah. So the main thing here is we are looking for fermentation, right? In normal curd, if we see the
so you already got a product with fermentation, right? I mean, you said you already have a mix. The 30 lakh, you will try other ingredients now.
Yeah. So this is just to get some flavor or that kind of things were there which we want to optimize more. So for that we will be doing trials with other things, other ingredients.
So have you taken this to any consumer or to panel as to why
actually,
you require
In our institute, we have conducted sensory trials, but the panel was limited. So in order to go in next stage, we need to get, produce in bulk, and then we'll be go for, like consumer trial in actual market. So that will be more feasible for, commercialization of this product.
Okay. Thank you.
Thank you.
Devika, thank you, Devika.
Akshay, there's a question I had for the GFI team. I can see from the 3 presentations that some of them have got to a prototype and others have a concept. Was there a requirement from you guys to reach a certain spot, or that's flexible?
That's flexible, Dr. Gurmeet. We didn't require them to reach a certain, let's say, TR level or whatever in terms of POC. That was not mandatory.
Okay.
What was the correction you mentioned? Or means the name of the last team? Is it not Millbiotics?
Millbiotics.
It is Millbiotics.
It is Millbiotics only, no? Okay, that's fine.
Dr. Narayanan, you can go ahead with your question, please.
Yeah, thank you. It's a very quick and straightforward one. So, hi, your USP was clear, highlighting on the millet-based sector. But then what I was wondering was, you have also highlighted about the non-dairy curd market in your presentation. And how do you plan to handle with the manufacturing and logistics of the existing competitors? So this was not clear. For example, when I say also manufacturing, also consider strain improvement when you have to introduce newer millets there. All right. So how do you plan to handle this?
Yeah. So in initial stage, that only I told like we need initial funding from research. So in that we'll be modifying the ingredients in order to get better product. And then in further stage, initially we'll be doing the third party production, and when we are established our own facility, then we'll be going for marketing these things. But initially we'll be targeting like major cities like Bangalore and Mumbai only. Then further we will be moving to tier 2 cities.
So you'll join hands with third party sectors, yeah?
Yeah. At first production stage, after like optimization and all, then we'll be going for third parties production. So one facility, just to add up a little, actually our institute itself is having a facility. So there we can go for this production, packaging, everything. And then we can, that institute itself can be considered as third party production. And then further, when we are targeting this big cities, metro cities, then there will be needing our own facility.
Thanks.
Thank you.
What's the rental cost? I mean, what per day, or how does it work? What's the
actually it works
for? Yeah.
Yeah. Actually, it works on like minimal how much as it is a government institute, so minimal charges will be there, just to like cover the electricity and other labor and all, that much only, not more than that.
You know, when we ask a question, you're making a pitch and you're asking for 30 lakh, you should be telling 10,000 rupees a day, right? Minimal charges.
Yeah, that's for processing.
I'll also give you minimally as a funding thing.
Actually, initially for some equipments will be needing for taking trials, because now we are not in the same institute, we have moved out. So initially for whatever 30 lakhs I have told, that will be needed for getting some basic equipments which are needed for conducting all the trials. And after that, we'll be thinking of this pilot scale processing and then going in market.
You have a table, a budget table for 30 lakh, how you're going to spend? How you arrived at the 30 lakh? Yeah.
Yeah, right now, like it's not there, but definitely we'll work on it.
Okay. Yeah.
Thank you.
Yep. Thank you.
Yeah, thank you, judges. Devika, if you could stop recording for a moment. Thank you, judges. I think we can move to team 4 now. The name of the team is Plantology. The technology area is plant-based ingredients. Their product name is also Plantology. The tagline is modern problems, vintage crops to the rescue. The primary team member's name is Indra T, and the other team members' names are Rajeshwari K and Vidyashree K. So they're vision aligned members with a common passion of unconditional love for animals and food technology background, and eventually drove them towards the alternative protein sector. And they're here to propose novel plant-based ingredient solutions using underutilized indigenous crops. So Devika, if you could please play that pitch. Thank you.
Did you know that 90% of the plant-based food that we eat comes from only 15 crops that are grown worldwide in monoculture and destructive means mostly? Of these 15 crops, only 2 can be sustainably scaled up to meet the global demand in the future. This prediction calls for immediate action. Indigenous crops, if given due attention, are poised to take a prime position in the sustainable development within the plant-based sector. Introducing plantology, modern problems, vintage crops to rescue. The main problems currently faced by the plant-based companies are lack of optimum functional properties, compromise on nutritional quality, and overall fewer ingredient crops available in the market. To counter this, plantology will offer novel ingredients from indigenous crops that have exceptional functional properties with superior nutritional quality. Our crops are better for you due to their high protein content and nutritional value. And for our planet, as they require less water, little or no manure, they enhance the soil microbiome and thereby increasing the soil fertility. Adding cherry to the top is their exceptionally low carbon footprint. Here's a look at the market potential of the plant-based sector. Overall, the plant-based ingredients stands at a colossal value of $34 billion as of 2022 and is growing tremendously every single year. We will offer our B2B partners novel ingredient solutions with high functionality, something that is missing in the current market. Of all the players in the global market, if you take lentils for instance, there are only 3 suppliers. And if you take our other 2 crops, mucuna bean and black gram, there are no players and thus we will be the market leaders. Research studies carried out in evaluating the functional properties of the fractions shows us that they have a huge potential in the plant-based ingredient space. Oil and water absorption capacity of red and green lentil concentrates are comparable with industrial standard yellow pea concentrate, indicating the potential use as plant-based meat or seafood ingredient. Similarly, for micronized and ultrasonicated black gram isolate and mucuna bean isolate. These use cases shows us their potential. Preliminary studies like these open up a huge realm of opportunity in the ingredient space. Now let us see a flowchart that explains the isolation of proteins in a pilot plant level. So initially the ground pulse is suspended in a specified amount of distilled water and mixed well to obtain a slurry. The slurry is then passed to a stir batch unit wherein alkali is added to solubilize the protein. The mixture is then pumped to a decanter centrifuge that will eventually separate the solubilized protein from the insoluble materials such as starch and fiber. The liquid is then acidified by adding sulfuric acid, which will precipitate the protein. Proteins can then be separated by using a solids ejecting centrifuge. The obtained protein precipitate is then neutralized by adding alkali. We obtain a wet isolate, which is finally spray dried to produce the protein concentrate or isolate. A period of 5 months will be allocated for isolating the proteins and optimizing the entire process. Proximate analysis will be carried out as per the AOAC methods and functional properties will also be estimated by following the standardized procedures. Both will occur simultaneously for a following month. The next 10 days will be spent in validating the results and identifying the applications of the ingredients in plant-based meat, seafood, egg and dairy. There are many other things in the pipeline which we will be focusing post-research. To carry out the research work for 6 months, we will require rupees 4,10,000, out of which 63% will be directly involved in the R&D. Post-research, we will set up a plant at a project cost of rupees 10.5 crores. The annual plant capacity will be 1,800 tonnes and the production cost being rupees 200. With a profit margin of 33%, our product will be sold at a feasible cost of rupees 300 per kg, competing with all the market players. By foreseeing some of the risks, we have developed some risk mitigation strategies as can be seen. We are pursuing final year bachelor's in food technology at Tamil Nadu Agricultural University. Myself, Indra, an aspiring entrepreneur with 8-month R&D experience at Plantish. Introducing Rajeshwari, an aspiring researcher who has worked on plant-based shrimp, and Vidya, an aspiring food safety officer. Both are jointly working on the development of plant-based meat using 3D printing. Thank you for listening. Please feel free to reach out to us for any further details or queries.
Thank you, judges. Any questions? The floor is open for questions. Thank you. Dr. Gurmeet, you have raised your hand from the beginning. I'm not sure whether you want to. Yeah.
Sorry, I think left over from last time. But yeah, I have a question. You mentioned in your timelines about 10 days after you have the protein for developing various applications, right? 10 days, right?
No, sir. So, yes, 10 days is for validating the results, as in we will be cross-comparing the results with the existing industrial golden standards of the plant-based industry as well as the animal counterparts. So, we will be referring and kind of coming up with the results, which will be purely theoretical. And this result will kind of give us an idea of how we are going to go about this research and which ingredient will be suitable for which final product. And post this and post research, we will be actually developing the prototypes and validating these primary results.
So these 10 days, where will you spend? Which laboratory? You require a laboratory or something to do that work?
For the entire duration, we will require a facility. We have shortlisted CFTRI as a potential facility, and we have also found out the cost of incubation there as well. For a 6-month period, that was briefly included in the cost estimation as well for the research. 1.5 lakhs of incubating cost would be required, and they have enough facilities for isoelectric precipitation. And we will also have an office there, so which will be useful in extrapolating the results and coming up with conclusions and what to work on about next following this.
Okay, thank you.
Thank you, Dr. Gurmeet. Vasman, please go ahead with the question.
Thank you for the presentation. Just want to double check with you because you actually have different plant sources for your final commodity. Are you looking into proposing like a mixture of these plant protein as your final product? So does that mean you also have an application design of what type of food product these commodity will be suitable for?
Yes, thank you for the question. And the primary aim is evaluating the functional property of each ingredient individually and kind of coming up with observations and results on how these ingredients will actually work individually. So some functional properties are as said in the previous researches as well, they are similar to that of the industrial standards as of now. And we can kind of develop blends and see the synergies between these ingredients. That will be as well post-research. But the fundamental aim of the research is to come up with the solutions for individual ingredients as such. And for developing these ingredients further on to optimize and improvise on these ingredients, we will also be looking into blends.
Okay. So you don't have a plan to do actual like application functionality testing, right? At this point, not yet.
We have the like the basic functional property testing. We have planned that out. But the actual product validation of the results that we obtain from this primary research would be post-research that will occur post-research that is further in the pipeline.
Okay, thank you.
Thank you.
Hello, so thanks for the presentation and the explanations. I have a question regarding the methodology that you are using with the isoelectric point. So your point is that you're using the pulses in lentils because they've added nutritional value like proteins and also other components. But if you're using the isoelectric point method for getting the proteins out, how do you want to make use of the other ingredients that are in the pulses? Because it's quite energy intense and chemically harsh treatment. How do you plan on recovering the other nutrients? And if you, so let's go for this one first.
Yeah, thank you, Iris. Indra, if you could keep your answer short as possible, I think we are over time. And if there are no other important questions, we can take them offline. Thank you.
Yeah. So yes, we are aware that the process is quite water and chemical intensive, and we are working on optimizing the entire process. So by optimizing, we mean not only the functional properties, but as well as the nutritional properties. So our fundamental aim is to deliver the maximum functionality at a feasible price, as well as delivering on the superiority of nutritional properties. So these are the three basic aims, and at every point of production, we will actually be focusing on all of these three things. And feasibility, we have worked out back-end calculation, and the functionality as well as the nutritional property will be evaluated at every stage of production to ensure that the highest quality protein is produced at the end. We have developed certain methods for each of these pulses. And by optimizing, we can, I believe we can actually deliver on the nutritional properties as well.
Okay, but just from a very practical point of view, how do you recover, for instance, antioxidants from the pulses if you're extracting proteins with the isoelectric point method using this chemical treatment?
Yes. Antioxidants, for instance, we are focusing solely on the functionality of the protein as well as the nutritional quality, that is, say, the PDCAS value and the digestibility of the proteins. So these antioxidants, they could be added as further like additives, like natural antioxidants that could be added at the end of the product. But the primary focus is on producing high quality proteins, which is mainly the PDCAS as well as the digestibility.
Okay, so you're just focusing on the proteins.
Yes.
Okay, thanks.
Thank you.
Thank you, Team Plantology. Thank you, Indra. I think we can move to the next pitch, Team 5. The name of the team is Plantiful. The technology area is plant-based dairy. The product is Milk It. Tagline is Milk It, a healthy plant-based milk powder for all your creaming needs, made of ragi and cashew. Milk It is delicious, clean labeled, and allergen-free. The primary member's name is Bhairavi Giridharan. The other team member is Yugandhara Indalkar. So Yugandhara, just to give you a snapshot of the team, Yugandhara has worked as a food scientist in startups and done her master's in food science from the University of Reading. Bhairav is a fourth-year electronics and communications engineering student at NITK, Surathkal. I think we can go ahead and just play the pitch. Devika, if you could please.
Hi everyone, I'm Bhairavi. Yugandhara and I form the team Plantiful. Today we are here to present a solution in the plant-based dairy realm as a part of the India Smart Protein Innovation Challenge, having explored a blend of proteins from India's indigenous crops to replicate dairy protein's functional properties. We would like to thank GFI India as well as the challenge sponsors for the opportunity. Having gone vegan, I realized the absence of adequate plant-based dairy options despite living in a metropolitan city. Gaining popularity in plant-based food habits owing to health, ethical, and environmental concerns inspired me to participate in ISPIC. By combining Yugandhara's experience as a food scientist and mine in engineering, we aspire to innovate in plant-based dairy. Most of us present here today understand the detrimental effect of meat, dairy, and animal waste products on our environment. Now take a look at this chart showing the annual consumption of milk in 2021. Clearly, India is the world leader in production and consumption of milk. Regardless of whether the person is vegetarian, non-vegetarian, or flexitarian, the diet of most Indians is dairy heavy. Today in India, many plant-based dairy products are available, like plant-based milk, curd, cheese, butter, ice cream, etc. However, there's very little innovation in plant-based milk powders. The ones present in the market are either soy-based or coconut-based, which has a strong smell and off taste, and that is not enjoyable. Hence, we pursue the idea of plant-based milk powder. To address this white space, Team Plantiful is proud to present our flagship product, Milk It. Inspired by the age-old infant formula popular in South Indian homes, Milk It is a millet and nut-based milk powder. Milk It can be used for a range of different purposes. The ratio of water and the method of reconstitution differs depending on the use case. It may be used as a creamer in tea, coffee, and smoothies. It may be used in place of milk solids for a plant-based version of milk burfis, pedas, and other Indian desserts that call for khoya. Creamy sabjis, gravies, and soups that call for curd or cream can alternatively use our product for a rich, creamy texture and mouthfeel. Milk It is safe to consume for everyone, ranging from 2-year-olds to the elderly. Milk It is made of just 3 ingredients: finger millet, cashew, and water. Ragi provides a nutritional content, specifically protein, that conventional milk carries. Additionally, being millet, ragi is less water intensive and thrives even in dry soils, minimizing the impact on our environment. Cashews mimic the creamy texture, mouthfeel, and the emulsifying properties of milk. The slight sweetness of cashew masks any possible off notes in the taste and flavor that may be caused by ragi. For ragi milk, malting is a necessary step. It involves cleaning, steeping, and germination of the grains before grinding it to obtain milk. Cashew milk is also prepared separately using a similar process. This is what the steeping and the germination unit will look like. Next, we make the cashew milk. When both milks are ready, we blend it together in an appropriate ratio to achieve both the sensory and the nutritional properties of the milk. The milk is then preheated, homogenized, and evaporated to total solids of 20 to 40%. The feed then goes into the drying chamber. A co-current flow is used, and atomizer is present at the top. A 2-fluid nozzle is used to spray the feed.
Spray drying is a novel technology with many recent advancements. However, it is still a costly process in India, but it is possible to produce a powder with desired properties like particle size and bulk density. Scale-up is possible as dryers of varying capacities are available. 100 kg of powder per hour to tons per hour is achievable. There is little protein denaturation or thermal degradation of particles as the process is fast and hence the minimum nutrient loss. So to produce the powder with desired characteristics and functionality, certain parameters are crucial. The inlet temperature of air is kept high to achieve a low moisture final product. The outlet temperature is kept low to prevent particle shrinkage and aids in uniform drying. The feed flow rate is controlled and kept constant along with the atomization pressure. The feed viscosity has to be less to provide fine droplets and hence a fine powder. The feed temperature is generally high before entering the atomizer because of the preheating step, and so it dries off instantly. We would be taking product trials at lab scale first. We also have set few spray drying conditions as seen through the table. However, it will involve many experiments to be followed to find out the best processing parameters and that it is helpful for process optimization. The aim is to achieve a powder of water activity between 0.2 to 0.3 and moisture content between 4 to 5%. We anticipate the shelf life to be 6 months. Most of the existing plant-based milks on the market today come at a price premium. The transportation and storage is also an issue as they need a cold supply chain. If at all they happen to be shelf-stable, they are subjected to UST pasteurization, which increases the production cost and hence the price of the product. Moreover, a range of stabilizers and emulsifiers are added. Milk It comes in a solid powder form. It is extremely versatile and can be used and reconstituted in a variety of consistencies to act as a creamer in beverages or curd for gravies. In addition, it is free from common allergens and clean labeled. The Indian cohort's familiarity with ragi can also provide to be a major driver for positive reception of the product. The powder will be packaged in stand-up pouches with a bottom gusset. The pouches will be of 200 grams and have an aluminum layer inside that will protect against the atmosphere.
a form fill seal machine is to be used for the packaging. We are currently at an ideation stage. In the next quarter, we aim to start product trials at lab scale and see the results. Also, simultaneously start fixing on quality raw material suppliers. In subsequent quarters, we plan to shift for pilot manufacturing and keep sending samples for consumer testing to gain valuable feedback from them. This will help us to improve our product. We then focus on product launch and expand our team. Based on our calculations, we would need about 10 lakhs to start production of about 1,000 kgs of the powder. We seek this funding to help us bring Milk It to the consumer very soon. Thank you all for listening. We are open for questions.
Yeah, thank you, Team Plantiful. Yeah, the floor is open for questions. Dr. Gurmeet, you have raised your hands. Please go ahead. Dr. Gurmeet, you're on mute if you're speaking.
So yeah, two things. One, you mentioned 10 lakh rupees. So just wanted to understand what you'll use it for and how did you arrive at that number? How long will you take to spend it and what do you want to achieve with that? And second, you mentioned some product attributes that you are targeting, right? One of them was free from it's fully natural and free from other ingredients, free from allergens also you mentioned. So what makes it so free from allergens, and what gives you the confidence that you don't need to add anything else to this powder for, say, dispersibility or emulsifying when people will stir it into water?
Oh, okay, Bhairavi, do you want to address the first question? Yeah, I don't know if she's there.
I'm sorry, I was on mute. Yeah, I'll address the first question. So firstly, coming to the budget, so the 10 lakhs will be used primarily in procuring raw materials and the processing, because as Yogandhara mentioned in the pitch, spray drying is actually it's quite an expensive process, at least in India right now. So yeah, it would majority of it would go into raw materials and the processing. And of course, we still have a bit of R&D going on. So it would primarily fund that. And as of now, we're going for a third-party manufacturing because that is the cheaper option for us. And as we scale up, we plan to shift into our own. But for now, it's third-party only.
So this is manufacturing cost, you're saying a lot of it will be manufacturing cost to meet your actual production.
Yes, yes.
Okay.
So to address your second question, we have mentioned in the salient features like it is allergen free. We do understand that nut allergy is also, we are using cashew and there is nut allergy present, but it's not that common in India. It is mostly seen in the Western parts. So the reason for mentioning that is, so that's the reason we have mentioned, called it as allergen free. And in terms of
just a point there, the first product on that table was also cashew milk, which was that it's not allergen free, and your cashew milk was allergen free. So I was just wondering why that is an allergen.
Yeah, so sir, that was from the company called Good Milk, and they are also adding oats to it. So that's the difference, because yeah.
Okay, and oats bring in the allergenicity.
So yeah, gluten is present.
Gluten is present.
Yeah, correct.
Okay.
So in terms of dispersibility, right now we are calling it clean label and we are not using any emulsifier. But because we believe that cashew already has around 45 to 50% fat content, and we are using ragi for the protein content. So we are assuming it to provide that emulsification by using the by leveraging the cashew's fat lipid content.
If that doesn't work,
then we will have to rephrase it and use lecithin at the end if at all nothing works.
Okay. Yeah. Thank you.
Welcome, sir.
Thank you, Dr. Gurmeet. Any more questions? Dr. Narayanan, please go ahead.
Yeah, just a quick one. So, hi, I was just wondering, when you talk about this milk product, milk powder kind of the final product, have you thought about addressing the challenge of identifying and convincing the right customers, thinking of the market in India? I mean, how do you envisage your customer education to happen? Or what would be your business strategy or business model, even if you think longer than that?
Okay, Yugandhara, I'll take that. Yeah, so as of now, our business strategy is basically to go like through our website. So like a direct to consumer, because I mean, it's quite a niche product. Yeah, you can't, I mean, consumers are not yet aware of it. And I'm sorry, can you repeat the first part of your question?
Yeah, my question is, how would you differentiate your milk powder from a variety and plethora of other milk powders available? And how would you educate the customers that yours would be a special one?
Okay. So right as of now, the milk powders available in the Indian market, they are either soy-based or coconut-based only. So again, soy and coconut are, I mean, yeah, soy and coconut are both allergens, and you know, especially coconut and soy, they have the strong off taste. So we are primarily aiming at combining, you know, cashews have a slight sweetness to it, so it masks any off notes from ragi. And another important factor in our product being that it is, it's actually made from locally sourced ingredients. And I believe that the Indian cohort is quite familiar with ragi as an ingredient. It's also reputed as healthier compared to other grains and cereals. So yeah, that's what we're looking at. Thank you.
Yeah, and thanks, Team Plentiful. Any more questions? If not, then we can move to the next presentation. Okay, so judges can have like 10-20 seconds to add their scores. Okay, now we can move to the next team. Team number 6 is ProSwap. That technology area is plant-based ingredients. The name of their product is ProSwap. The tagline is "Find your future protein here." The primary team member's name is Vijay M, and the other team members are Soumya R and Abhirami A. So, Devika, if you could please go ahead and play the pitch.
A very warm greetings to all present here. I'm Soumya from the team ProSwap, and our tagline is "Find your future protein here." We are from track 1, and the technology area is plant-based, and the end product focus is ingredients. We are very much thankful to Good Food Institute and the Indian Smart Protein Innovation Challenge for giving us this wonderful opportunity. Moving on to the next slide, we are a team of 3, myself, Vijay, and Abhirami. We are currently pursuing a master's in the relevant area of food science and technology. In this project, we have I myself are focused on budget and timeline. Vijay and Abhirami have focused on the scientific aspects and technical aspects of this product. So the next is focus, the exploration of protein from India's indigenous crops for the functionality to produce plant-based meat, dairy, seafood, or egg alternative is our primary focus. And moving on to the next slide is the vision to develop an efficient, cheap, protein from indigenous variety of crops for such as
Audio is a problem.
A very warm greetings to all present here. I'm Soumya from the team ProSlab, and our tagline is Find Your Future Protein Here. We are from track 1, and the technology area is plant-based, and the end product focus is ingredients. We are very much thankful to Good Food Institute and the Indian Smart Protein Innovation Challenge for giving us this wonderful opportunity. Moving on to the next slide, we are a team of 3, myself, Vijay, and Abhirami. We are currently pursuing a master's in the relevant area of food science and technology. In this project, we have I myself are focused on budget and timeline. Vijay and Abhirami have focused on the scientific aspects and technical aspects of this product. So the next is focus, the exploration of protein from India's indigenous crops for the functionality to produce plant-based meat, dairy, seafood, or egg alternative is our primary focus. And moving on to the next slide is the vision to develop an efficient, cheapest, functionalized protein ingredient from indigenous variety of crops for production of plant-based products such as plant-based meats, dairy, yogurt is the primary vision. So there are certain challenges in developing and plant protein isolates. It could be from nutrition. There are anti-nutritional factors and digestibility issues. In sensory, it is undesirable flavors, and in techno-functionality, it could be indigenous structural features for aqueous solubility and certain other features which is needed for any plant-based alternative in the market. The rationale of approach is increased carbon footprint due to the consumption of animal-based products could be tackled with the use of plant-based products. Food safety, nutrition, loss of biodiversity could be monitored, and the agricultural land usage, eutrophication, and the usage of chemicals and antibiotics could be reduced by the usage of plant-based products. So the ideation involves obtaining protein isolates and improving the functional properties, blending of isolates, and finally providing them to be a nutritious, structural, and palatable product. So we have taken indigenous protein source from chickpea, pearl millet, and proso millet. So why we took them is mainly because of the protein content, which is globular in nature. It has good structural moiety, and textural properties could be replicated in any plant-based meat or any other alternatives. We are functionalizing them to improve the properties like emulsification, etc., in order to use in a plant-based meat, seafood, etc. So the techniques involved in functionalization, which is ultrasound. Here we are using changes in the protein structure, and the solubility, surface hydrophobicity, and the molecular flexibility could be altered using this treatment. Moving on to the next topic, which is enzyme hydrolysis. Here, the formation of bioactive peptides occurs, and the protein isolate level could be elevated, and the fat absorption capacity could be increased, and certain off flavors could be removed, and the hydrophobic amino acids are present. So bioactive peptide, this is an additional and benefit to our product. So what are they? They are tiny fragments of dietary protein consisting of 2 to 20 amino acids having a molecular weight of less than 3 kilodalton and promote additional health benefits such as offering immunity. So the significance of products are low saturated fats, like low levels of low density lipoprotein, and they are indigenous protein which is allergen free and gluten free. The bioactive peptides will offer immunity, and in agriculture increase the productivity of traditional crops, and the reduction in anti-nutritional compounds such as trypsin inhibitors are present. So the process flow involves obtaining millets and chickpea, cleaning them, processing them, and defattening them, and subjecting to centrifugation. The supernatant is subjected to acid-base precipitation, and the precipitate is then finally freeze-dried and stored. Now the process involves ultrasonification, in which the isolate is optimized for regular intervals. The enzyme hydrolysis, the degree of enzyme hydrolysis will be controlled, and in the screening of hydrolytes, screening of peptides formation using STS page is done. And in step 4, screening of biopeptides, here the protein database search for relevant active peptide is done. Finally, optimization involves blending of functionalized hydrolytes. Moving on to the next slide is the timeline. It involves 4 phases, starting from raw materials procurement, processing them, and functionalizing them, and scaling up. There are certain things to be noted in certain stages which could be rectified while proper analyzing. Moving on to the next slide is data prediction. Individual PDCAS and DIS score is calculated for understanding the protein quality. Biology of plant protein blend is studied, and the amino acid composition is also studied to know the presence of essential amino acids. Here, these are the protein like chickpea, proso millet, and pearl millet are found to have high protein concentrate and isolate in them. So in average, we could get around 90 to 92 gram of protein isolate. So they have also good functional properties like water holding capacity, oil absorption power, and emulsification and foaming properties, which is needed for every other plant-based meat alternative in the market. Also, they have additional benefits of essential amino acids in them, which could be used for the nutritional composition of a product. Moving on to the next slide is the financial costing of solution. We are aiming the RSP around 2,500 to 3,000 per kg, and the retail profit margin would be around 40%. In general, we saw that there are no protein isolate containing millets and chickpea. So around most of the products available are with wheat, soy, and pea protein isolate. So this could be a novel and innovative approach in terms of marketing. The scale-up involves 10 to 20 workers on on-site, and process production improvement is needed, and the cost reduction could be done after certain repeated trials. Moving on to the next slide is the timeline. It starts from 3 to 4 months for building an MVP, and also 3+ years for the pilot plan to get a proper validation. And the budget involves 8 to 10 lakhs for a pilot scale and around 2 to 3 lakhs for lab scale. So yeah, these are the references. Thank you.
Yeah, thank you for the presentation, Team ProSwap. So judges, the floor is open for questions. Dr. Gurmeet, I see that you have raised your hand again, so please go ahead.
Yeah, thanks for the presentation. Question, when you extract the proteins, what do you do with the rest of the stuff was one. Second, when you are mentioning the properties right now of the proteins, this is of the isolate or is it of the ground material, right? I don't know whether, I mean, for example, millets ka, it's purified protein or it's the millet ka property jo aapne likha hai. The cost will depend on what you do with the rest of the material, right? So have you thought of what you'll do with the rest?
Like that's the cost of the protein isolates. Greetings, sir. That's the cost of protein isolate that we are obtaining. The rest we have not calculated. The only thing is the isolates cost is that.
So that isolate cost is right now 2,500, 3,000 rupees a kg is what you're saying.
Yeah. Yes, sir.
And that assumes that you are going to throw away whatever, because 15%, 10 to 15% protein from ragi millet, remaining 85, 90% is zero value, you're saying. Same with chickpea, 25% protein, remaining 75% is waste, yeah? Or have you thought of what you'll do with that, where you will sell that? Yeah.
That we have not proceeded. So like we calculated the manufacturing, the one we are producing, not the throwing part that we have not calculated.
Okay. So your cost could actually become lower if you find value for or a market for that.
So
right?
Yes.
Maybe
cost
we can
reduction could be done after repeated trials.
Maybe we can extract the starch from the remaining, and we can use it also in the plant-based protein, because it is rich in starch also. We are going to go with the same defatting process and all, and so hence we can use that also in our product.
Mm-hmm. Okay.
We haven't really thought about it. We were focusing on the protein, and maybe we could do it in our future.
Yeah, I mean, you will have to. Any project will need to look at the full. The soy is available at a low cost because there is a use for the rest of the stuff, right?
Yes,
so
yes, sir.
You are at 2,500 rupees a kg for the isolate. What's the cost of soy isolate, for example, today?
Starting from 1,500 to 5,000, sir. It is differing
depending
upon the
company.
Isolate or structured protein?
Isolate, I guess, sir.
Isolate would be few hundred rupees a kg. So I'm wondering
why would around 300 per kg, sir, like that.
So why would anybody buy a 3,000 rupees a kg unless it is a very specific need? Is there a specific property of your protein that you are thinking so that people will pay 10,000 rupees more? I mean, 10 times more? Any thoughts? Anyway, those are things to look at. Yeah.
Yes, sir. Also, maybe since we are moving in a plant-based side, maybe the early birds who are exploring new food products will buy our products. And after that, we have to gradually, after repeated trials,
we can reduce our cost.
Yeah.
Reducing
Okay.
the cost also.
Thank you.
Thank you, Dr. Gurmeet. Dr. Madhusudan, Madhuji, if you can go next.
A quick question. See, what I recall is protein hydrolysates don't add the nutritive value, but you seem to have these production of hydrolysates in your process, which is adding to the cost. So what is the justification for hydrolyzing your native protein?
Could you explain, please?
Did you get what my question is?
Sure, but we are mainly focusing to improve that functionality to get retain the properties what we are usually in the meat, egg, and other milk properties and foaming capacity, emulsifying capacity. So we are just focusing in a research kind of thing to make it as a very functionalized one by increasing the water holding capacity and other emulsifying properties. So we are using these techniques to improve these. So many literatures and researchers are also doing same kind of things, but we are focusing on the indigenous variety which is never explored now. So we are only producing the ingredient. We have to try that, sir. So no one has have tried as an ingredient, just for a research purpose they have done, but we have to make it as an ingredient. So we have to make a tray through the enzyme hydrolysis and other things, sir. We have to check and analyze and screen what effect will have. Like whether the literatures are saying the same correct things, or and we can improve the much more better things like that.
Thank you.
Yeah, thank you, Dr. Madhusudan. I think we can move ahead to our next team in the interest of time. So the next team would be Plantoyali. In the meantime, when judges are writing score, please make sure that you're writing your score to row number 10, where ProSwap has been written down for team, basically ProSwap. Moving quickly to Plantioli. The technology area focus is plant-based dairy. The product name is Sliced. The tagline is "It's delectably cheese delicious." Team lead here is Shakti Virendra Dahe, and the other team member is Lucky Madesia. So Shakti Dahe is currently pursuing a BSMS in Biological Sciences from ISPIC Bhopal and is interested in molecular biology. He's also won a bronze medal in IGM in 2021. Lucky Madesia currently pursues Masters in Food Processing and Nutrition from SNDT Pune institution. So she has developed sweet potato nachos, masala bruti, and many more previously. So over to Plantioli.
Hello and good evening, everyone. We are Team Plantioli. It is delectable and delicious. Our team is one of the participants of ISPIC 2021. Based on the track 1, we are working on indigenous plant-based product formulation. And we want to thank GFI India for providing us this opportunity to work in the smart protein sector. So firstly, we would like to introduce ourselves. I am Shakti and I am currently pursuing BSMS in Biological Science from ISPIC Bhopal. And my teammate is Lucky Madesia, and she is currently pursuing her Masters in Nutrition and Food Processing from SNDT College, Pune. I have expertise in protein biology and she has expertise in food processing, and I have experience in bakery segment product development. So we find ourselves a good team with a diverse background, having good knowledge in the respective fields. Now coming to the problem, as we all know that by 2050 we might face existential crisis. The food available will not be enough to feed the population present on Earth. Considering the same, we will have to opt for alternatives which are more sustainable. By Smart Protein Challenge, we observed this problem and got to know that plant-based food might be a solution. As our team's interest was inclined toward dairy products, so we started exploring sustainable alternatives of cheese. And we found that plant-based cheese is too expensive. And also the plant-based cheese industry is saturated with expensive nuts like cashew and almonds. And not everyone in the nation can afford it. We found that there is a big gap in this industry, no one is aiming for the people present in the lower part of the pyramid, that is middle and lower class people. So to target the same set of audiences, we came up with a solution. We would like to present you Sliced. Sliced is a plant-based cheese product based on the water chestnut, that is Singada. We chose water chestnut because first of all, it is one of the most important minor crops of India. It is rich in fibers, have very less calories, and have many other nutrition benefits. It is a good option for diabetic and intolerant peoples. So now I would like to introduce you to our product. So our raw material is Singada, and in addition to that, we are using plant-based essentials which are required to make cheese. These essentials include sorrel, tapioca flour, agar, and kyber. So basically, we are using a clean label for formulation of our product. The experimental design of our product is conventional. After selecting good quality chestnut, they are washed and peeled off. Then balancing is done. That is enzyme inactivation, followed by grinding to make the puree and production of acid. Then the rennet is added, which results in the coagulation of proteins and formation of curd. Then the curd is cut into small pieces so as to make them easier for cooking. Cooking is done at 38 degrees for 40 minutes, and then the whey is drained so as to obtain thick mass of cheese, which is then mixed and pressed. Then a brining is done to decrease the moisture content of the cheese, and this cheese is then packed and is ready for consumption. Now I would like to highlight some pros and cons of our product. Our product is rich in fibers. It contains more than 3 times the less calories as compared to others, and the fat concentration in water chestnut is around 99% lower than dairy cheese. The protein concentration, however, lower than dairy, but is significantly higher than the plant-based cheese. Now coming to the options available in the cheese market, currently animal-based cheese dominates the market as it have two incredible advantages. That is high protein content, and second is low cost. Whereas a plant-based cheese suffers in both this segment, the costing is very high and also the protein content is lower. Now here comes our product. Currently our product is targeting on only one segment, that is price. So Sliced will be priced nearly as same as the plant-based cheese, and the price may even reduce because in a study by Nandy et al., just by providing 50 kg of urea, the production of water chestnut can be increased by nearly twofold. So Sliced can be priced competitively with the animal-based cheese. Now coming to roadmap. So we are currently in the addition phase and hope to build our prototype soon. After the formation of prototype, we will test and validate it for the market, followed by a certification stage. After that, we will add a co-founder from economics or business background to help us in building the strategies and marketing and product launch. We are targeting the B2B market first, and then we will launch B2C in future. So judges, we want your guidance and financial help of around 2.5 lakh rupees for the product's research and development, which include the cost of raw materials, some basic equipments, and other miscellaneous costs. In addition to that, we need infrastructural support and mentorship for the development of our minimum viable product. Thank you so much for contacting us. Kindly use LinkedIn, and these are our IDs. So thank you very much.
Thank you, Team Planto Yali. Judges, please go ahead with your questions.
Yeah, I can start. Yeah, hi, thanks for your nice presentation. So I was just wondering, you started with this water chestnut, but then in the near and midterm future, do you also have intention to broaden your pipeline? Will it be a multi-product plant-based cheese, or how do you see that?
Sir, actually means initially we will be focusing on water chestnut, but according to the response from the audiences, we might change our directions. So it will be totally based on the audiences.
And how do you plan to identify your audience, the right audience?
Sir, currently our audiences are basically the one who can who are willing to who want to afford the cheese, but due to some price they can they hesitate. If they are willing to purchase our product, we will first do some market survey. Basically, are they willing to buy it or not? So according to the survey, we will change our guidelines of the product.
Sure, thanks.
Thank you. Dr. Gurmeet, please go ahead. Dr. Gurmeet, you're on mute.
Why water chestnut, Shakti? Protein levels are not exceptional, right?
Yes, sir. Actually, the market is saturated with mostly saturated with cashew and all. So in the recent survey, it was found that cashew milk source segment contribute the largest in the revenue share. So we thought that why not go with something which is which can be used and is affordable. It can be affordable to majority of the public. So that's why we opted for some cost competitive alternative.
What's the cost of Singhada?
Sir, it cost ranges from 75 per kg to 150 per kg.
For how much of protein in a kg?
Sir, in kg, I am not sure, but around in 100 grams, it was, sorry, in 4 ounces, it was around 0.5 gram something.
100 gram में 0.5 gram. I think 100 gram about 3 gram के आसपास होगा. So 1
0.3. It was 0.3 per 100 grams.
Yeah. So that's very low, right? I mean, so 100 rupees a kg आप दे रहे हैं सिंघाड़ा के लिए और
but it is rich in fiber and it have a low calorie compared to other animal cheese and the other vegan cheese.
And sir, actually we were targeting the we are currently targeting only for the cost, not for the protein content. We will we can add some blend it with something so that the protein content is increased. We can surely do that.
Okay, I'm not very clear what the proposition is then and why water chestnut and how calories come into play, because calorie for a protein is very similar and calorie for a cheese. So maybe I'm not clear on the proposition. Yeah. Anyways, okay, thanks. Yeah.
Thank you, judges. If we do not have any more questions, I think we can move on to the next team. So for Team Plantioli, please add your scores to row number 9. Moving on to the next team. Our next team number 8 is Smart Media. The technology focus area is cultivated meat, media formulations. And the product is basically using spirulina hydrolysates. The tagline is spirulina hydrolysates redefining the cell culture media by replacing the animal serum in cell-based meat applications. The primary team members' name is Mandala Puyadidya. The other team members are Jay Gupta, Naveen Kumar, Komatlapalli. This is the basic introduction is. This is Smart Media, which includes 3 members. Mandala Puyaditya is a research fellow at Activist Healthcare with specialization in stem cell regenerative medicine and molecular biology. Naveen Kumar is a junior scientific officer at Newberg Diagnostics Private Limited with specialization in food microbiology and molecular biology. Jay Gupta is an undergrad in MIT University who is pursuing biotechnology and is a minor in business management and has interest in food biotechnology. So over to Smart Media.
We Smart Media, things grow better with Smart Media. We are in track 1 innovation cultivated meat. Our problem statement, innovative solution for the low-cost production of recombinant albumin or an equivalent. Meet our team, Yadidya, Naveen, and myself, Jay. All have various specializations ranging from stem cell regenerative medicines to various other specializations in micro and molecular biology and in food biotechnology. Our mission, the world's population increasing rapidly and it's requiring immediate action to transition towards a healthier and more sustainable food system. comes the smart media, an animal-free, a non-GMO, and a free animal cruelty cell culture media that has a prominent role in producing cell-based meat, where our product is going to redefine the industrial standards. So why are we drifting away from the conventional meat? Conventional meat industry is one of the most harmful way to generate an Inca food. Around 70% of the fresh water, more than 44% of the antibiotics, 33% of the arable land, and 20% of the global energy is used to produce your old style conventional meat. Yes, there is an alternative method to develop meat. Comes the cell culture meat and media. Cell culture meat can be developed directly from the animal cells by growing them under optimal conditions. Seeing this all, there are multiple challenges from cell lines to cell media to scaffolding. And we are focusing on cell culture media, which is highly specialized liquid. It provides nutrients to cells to grow, which also have basal media and growth media. Moving on to the problem, now cell culture media is used as a pharma research grade product, and it is the major cost driver while developing cell-based meat products. 99% of the total cost is because of the animal serum. Fetal bovine serum is the major animal component used in the cell culture media and serves as a source of growth hormones and growth factors. Problem with FBS includes batch-to-batch variation and contamination issues. Along with the animal suffering is involved in producing FBS, which is highly unethical. This cumulative factor drove us to work towards producing a cost-effective and animal-free cell growth media. Now my colleague Yadida will continue.
Yeah, when coming to the solution, after going through the brief literature, we are proposing spirulina hydrolysates can substitute animal serum in cell culture meat. Our USP includes no animal cruelty involved in producing our product and also economical when compared to the animal serum and less batch-to-batch variation as well. Now, somehow you may think, what are hydrolysates? Hydrolysates are nothing but the short peptides which can be generated using plants or microorganisms as a source, where protein part can be isolated from the source, followed by enzyme hydrolysis. And further purification gives hydrolysates, which can be used in cell culturing as a substitute to animal serum. We have gotten a good literature backup concluding the usage of hydrolysates generated from plants or microorganisms that can substitute the animal serum. Phycocyanin is a major protein present in spirulina and can be extracted from it. A recent publication in 2021 has shown that phycocyanin has improved cell growth and proliferation under reduced animal serum conditions. A small data from this paper you can see in this graph. When cells grown using 10% FBS, it has shown a good cell growth, and the cell growth is drastically downregulated under 5% FBS condition. But when cells were treated with phycocyanin under reduced animal serum condition, it has shown a positive cell growth, concluding that phycocyanin can substitute the animal serum to some extent. And we propose the usage of spirulina as a hydrolysate source. But why? Spirulina is a microalgae used as a nutraceutical worldwide as a supplement of protein and vitamins in our diets. It consists of 50 to 70% of protein, means it's 3 times greater in protein content when compared to plants, which makes it a better source of using it as a protein hydrolysate source. Scientifically, it is proven that peptides obtained from spirulina have shown a lot of bioactivities, including anti-tumor, antibacterial, antioxidant, and iron chelating activities.
Coming towards the competition, we saw many companies working directly or indirectly in the development of cell culture media, most of which are indirect, like Biobatter, Bias, Richco, which are working towards animal-free protein add-ons for the media, and other media companies like Thermo Fisher working directly in the media production but has the animal component to it. Then comes our product, Smart Media, which is 100% animal-free and affordable. So moving on to the market analysis, seeing the USA, Europe, and India, there has been exponential growth in all protein sectors and startup, which is currently leading by the US, followed by the Europe and India. Estimated around 76% growth in the cultivated meat industry in India by year 2023. Seeing this growth in the cultivated meat industry directly refers to an increase in the cell culture media as well. Analyzing this chart, we show a steady growth in the investment and funding as well.
For executing our proposal, we need a clean room cell culturing facility. Fortunately, we have gotten an opportunity to work with Acrivis Healthcare Private Limited, which is a startup working on stem cell regenerative medicine. A brief overview on the methodology part. Here we're going to explain where we procure spirulina strain from National Center for Industrial Microorganisms, followed by its cultivation and harvesting. Using freeze thawing or ultrasonication methods, protein isolates can be obtained from spirulina, followed by enzyme hydrolysis using different endopeptidases, and the obtained hydrolysates can be used for further testing in cell culture. These are the 4 experimental setups which we would like to focus on: a positive and a negative control, followed by cell cytotoxicity studies when treated with hydrolysates. And the third parameter is to test for the cell growth and proliferation when cells are treated with spirulina hydrolysates under reduced animal serum condition. And the fourth parameter is to test the cell growth when cells were treated with only spirulina hydrolysates, excluding the animal serum part. Coming to the expected outcomes, with our product, we are confident about the positive cell growth and negative cell cytotoxicity, which would help us move forward to further proof of concept studies. Further challenges that we need to focus are to plan for a cost-effective methodologies that would reduce the price of the final product, like using food-grade enzymes instead of analytical grade in the experimentation part. Regulatory challenges and quality parameters, quality assessment parameters include safety and efficacy of the product are necessary before releasing the product into the market. When coming to our current progress, we are standardizing the cultivation methods, especially we are trying to cultivate spirulina in a closed photobioreactor system. Here you can see a few microscopic images of spirulina, which we have taken from our first harvest. Simultaneously, we are working on a protein isolation part where we used freeze-thawing method to isolate proteins, and we successfully isolated the proteins. In conclusion, our product is animal-free, economical, and will be commercializable to the cell-based meat industry. And we are proud to be a part of this upcoming alt protein revolution. Thank you. We are ready for questions.
Yeah, thank you, Team Smart Media. The floor is open for questions for Team Smart Media. So judges, please. Yes, Iris, please go ahead and ask a question.
I have a question regarding the cost. So how does the production of phycocyanin and using phycocyanin with all the production and downstream processing and purification that you have compared to using BSA?
Yeah, currently we have not done until phycocyanin production. Currently we are under spirulina cultivation only, where we found out producing spirulina is not a big issue for us when it comes to the commercial point of view. But isolating the phycocyanin from it would be a little bit issue, which we are working on it right now. And using some other than chemical-based extraction methods, we are trying to focus on crude spirulina hydrolysates instead of focusing on phycocyanin itself.
Okay, but can you decrease the cost of the culture medium for the cultured meat by using phycocyanin?
Obviously, like instead of using the main misconception over here is till now cell culture meat is used as a premium research grade or analytical grade product. But when it's coming to the cell culture meat, which is a food grade thing, we want to use, instead of using the analytical grade products over here, we want to use the food grade substitutes, which are little bit less costlier when it's compared to the analytical grade products.
Also, Iris, there is a, like comparing to the traditional products which we see in the daily market, there has been addition of many other product components and ingredients like FBS, their growth factors, there is a multi array of products, ingredients which are added to the media to support it. But also they are pharmaceutical grade or they are analytical grade. So our product is food grade material, which only encompasses about phycocyanin and spirulina hydrolysis to support the cell growth and all. So we are drastically reducing the component and ingredient input in the media, as well as keeping the same growth compared to other materials. Yeah.
Okay, thanks. Yeah, I mean, I know about the studies that are using microalgae components for using it for cultured meat, right? But still, it's very costly to produce microalgae. And also you could use the microalgae themselves for food. So okay, but thanks for the
Actually, we have done this spirulina cultivation, and what we concluded is within $1 to $2 we can able to produce 1 kg of spirulina over here. That is very far, very less costlier to produce it. Spirulina.
Okay, thanks.
Thank you, Iris. Dr. Madhusudan, please go ahead.
Hello.
Hi, sir.
Hi, sir.
Yeah, I just wanted to, of course, unless you do these things, you wouldn't be knowing it anyway. But the point here is, I think some of the setup that you had on the experimental details, that's not going to be that easy because, as you probably know, cell cultures have to be adopted. It is not that, if you just had 1 to 10 milligrams or whatever of spirulina extract or hydrolysate, it's not going to work. You have to train the cells. So don't look at one exposure to the serum-free media and make any deductions. So, but your experimental design says so, but I'm sure you have better ideas to train the cells before you. Training is very important, optimizing it for them.
Yes.
So I just thought I'll tell you. But also safety is a great issue because glutamine can't be there, endotoxin can't be there. I don't know what else that gets added in a spirulina culture need to be there. So safety is the most important thing, and how many kinds of cells and optimizations are critical. So I thought
Yes,
I
sir, for
can't really
follow.
comment whether it works or not. So, but these kind of precautions are important to make sure it didn't
Yes, sir,
work or
more
work.
than
Yeah, go ahead.
Along with the POC studies, the further challenges which includes the quality control only. So like to find out the cytotoxicity levels and any other further trace toxic metal elements in this final crude product of the spirulina hydrolysis. These are things we want to focus on after we're getting completing the POC studies, after getting the positive results over cell growth and negative cytotoxicity.
Sir, also coming to your first point, like training the cells, it's a valid point, like training the cell lines to a particular type of cultured media to support that certain growth ingredients and component to grow itself, to sustain itself. So we will be working towards it. Yeah.
Yeah, and actually we want to we're putting experimental setup in such a way we're creating a gradient kind of right from in the FBS the optimum concentration of protein is 5 to 6 milligrams per ml actually. And how we are designing our experiment is we are starting from 0.1 mg per ml concentration to 10 mg per ml concentration. We are putting a gradient kind of protein hydrolyzed setup in the experimental part.
I understand all that, but what I'm trying to say is one experiment is not going to get you home.
Yes,
I mean, you have to train it. That's all I'm saying. Thank you.
Yes,
definitely.
Thank you.
Thank you, Dr. Rao. Dr. Narayanan, please go ahead.
Yeah, very quickly. Just to complement Dr. Madhusudan Rao's comment, the very essence of serum lies in its diversity, yes? So also, just in case I was wondering if you want to make sure, if your spirulina hydrolysates, how diverse would they be? Because at the end of the day, you need to ensure proper addition, binding, transport, and all the other factors that will be essential to have your 3D structure at the end. So I was just wondering if you thought about it. But my question actually is, what is your ask in terms of financials? Because that was a bit missing from the presentation. So, or the time, and also the timeline actually, but timeline is understandable, but at least the financials, could you comment on that?
So basically, currently we are on the POC itself, like we are designing our proof of concept and all. So after that, we will be doing our preliminary research. If we are confirmed with that, we will be working in two ways. Like we'll be approaching some companies and laboratories to work with us and have a collaborative projects and working towards that. Or either after that, we can have our own financial setup, like we will be asking some kind of funding. But currently, the current stage, we are not defined for the financial state of how much funding we are requiring. Because there is a means defining or creating a new cell line, creating new media. There's a huge and expensive labs are required, like clean rooms are required, expensive bioreactors, machine, everything is required. So currently we are at POC itself, so we are not asking for the financial side.
Thank you, Dr. Ashutosh.
Just small thing is not a question, but a point we just want to make claim that please also explore dairy. I see that they have not exactly the cell culturing of this, but cultivation and isolation and test the functionality of the proteins. They have protein isolates and which are based on, so that you can spirulina particularly, I think. So that you can look for. That's the point we just I want to make. Thank you.
So definitely.
Very good. Now, this is Tata Energy Research Institute, something like that.
Yes.
That's all. That's all from my side.
Thank you. Thank you.
Thank you. Yeah, thank you, Dr. Ashutosh, and thank you, Team Smart Media, for your presentation in the Q&A session. We can now move on to the next team. Just to highlight here again for the judges, Smart Media is row number 12. To please add your scores there. So moving quickly to the next team, team number 9. We have 3 more teams to go. Team number 9 is the name of the team is Like Milk. The technology segment is plant-based dairy. Their product is also Like Milk. The tagline is better, delicious, and kindlier plant-based milk. Hashtag ahead of the pack. The primary team member is Devesh Singh. Other team members are Anupama Lakra and Sabitri Manna. So Devesh Singh has a BTech in food technology and Anupama Lakra has an MTech in food safety and quality management from NIFTM. Sabitri Manna has a master's in food science and nutrition, Pondicherry University. So over to Like Milk.
Like Milk, better, delicious, and kindlier milk ahead of the pack. Our team members consist of three members. Me, Devesh Singh. I am currently pursuing my BTech in food technology and management from NIFTM. Anupama Lakra did her MTech in food safety and quality management from NIFTM. And Sabitri Manna did her MSc in food science and nutrition from Pondicherry University. Problems which Like Milk will solve. Lactose intolerance is a disease of small intestine mucosa that precludes the digestion and absorption of lactose from the diet. Cow milk protein allergy is an abnormal immune reaction to cow's milk protein, which may be due to the interaction of one or more milk proteins. Will solve the problem of gluten intolerance and nut allergen protein, as gluten-rich plant protein is not selected likewise. It is nut-free compared. Ragi is rich in iron and calcium. Incorporation of mung bean, which has emulsifying properties, will help in reducing the extra amount of additives. Unique selling property of Like Milk is it is a combination of legume protein, mung bean, vegetable protein, potato, cereal, ragi. So, ingredients will complement their nutrition deficiency. The processing of Like Milk is based on hurdle technology, which is the combination of novel technologies aiming to prevent denaturation of proteins and enhancing the physical properties of plant proteins, thereby delivering the nutritious, allergen-free, shelf-stable product. The use of sugar alternatives and phosphate alternatives overcome the problem of high calorie and side effects used for the processing of plant-based milk. The use of indigenous crops adds environmental and socio-economic benefits, which we will talk more about in the later slides. We'll give new options to lacto-ovo-vegetarian, lacto-vegetarian, ovo-vegetarians, strict vegetarians, and vegan. The reason for gaining popularity over dairy is that usage of antibiotics being in animal feed in order to increase the induced milk production and milk being adulterated with caustic soda or white paint are making people more conscious about their milk choices. Products and experiences with both sustainability and health benefits will drive greater appeal as people move from careless to responsible consumption. We have chosen three ingredients which are potato, ragi and mung bean after a lot of research and comparison. The formulated blend can be infused with tea flavor and be ready to drink. Instant tea flavor blends mixed powder and is ready to mix type of beverage. Blend in powder from which can be incorporated into bakery mix like cereals, bars, thereby adding the goodness of plant milk and replacing dairy protein. Talents needed to make Like Milk are 5 skilled manpower, 5 semi-skilled manpower, and 5 to 10 unskilled manpower. The 5 skilled manpower are 1 manager, 1 R&D specialist, 1 QA QC from the department, 1 purchase from the department, and 1 from the market. First, we take our plant protein, which consists of our 3 unique ingredients, which are ragi, mung bean, and potato, and dissolved in water and buffer solution. Then they are mixed using a high shear mixture. This mixture is then filtered using a microfiltration membrane to remove impurities to obtain coarse emulsion. Additives are added as per the formulation of the product and then subjected to homogenization via microfiltration. Finally, plant-based milk emulsion is ready for final processing treatment for shelf-life enhancement, that is hurdle technology. At last, packaging and storage is done. We are aiming at 250 to 450 liters rupees per liter of plant-based packaged milk products. For this, we need a total budget of 30 to 40 lakhs and for scaling up 70 to 85 lakhs. It's not cost competitive yet as it is costlier than the other products present in the market. It is a blend of unique ingredients due to being plant-based and having unique ingredients as compared to other plant-based milks present in the market and have many environmental and socio-economic benefits. We need to focus on consumer education to make them realize why like milk is better than the other plant-based milks present in the market. Scale up of this solution will not be super easy as the ingredients are not so common in the plant-based milk market, and we still need to prepare a prototype. We will have to focus on consumer education, and it will require 1 year of time frame for the execution of this solution. Following are the consideration in order to prevent and eliminate physical, chemical, and biological hazards. Sending finished product samples to FSSAI approved notified labs, compliance to food safety and standards, and following good manufacture practices, use of food grade materials for equipment which is coming in primary contact with food material, following good hygienic practices, pest control management, developing a training calendar to create awareness among food handlers, to maintain uniformity and consistency, ensure a continuous supply chain of raw material from approved suppliers, use of sensors, quality checks, metal detectors to give assurance of safe food. Here is a list of environmental benefits that like milk has. As you can see, the ingredients that we chosen use less land, fewer greenhouse gases are produced, and uses less water. Here we have list of equipment additives that we are going to need and to make like milk, and we have also listed the companies we are going to get them from. Here is a list of primary ingredients and their suppliers. Thank you. We hope we can make like milk reality.
Yeah, thank you, team Like Milk. The floor is open for Q&As now.
Yeah, hi, I can start. What is the shelf life, expected shelf life of your product? I don't think there are any participants.
Yes, let me add them.
Yeah, great. So thanks for your presentation. I was just wondering about the expected shelf life of your envisaged product.
Sir, we are expected that 12 months will be our shelf life of our product. Since we didn't even made that prototype, so we can't say like.
No, not the production time. I'm asking about how long can we keep this milk? Should we store it in the refrigerator for some time, or is it already okay at room temperature for quite some days, or how does it work?
Okay, so like we have done like some research analysis based on some non-patent and patent literature. So they have like 4 to 5 months shelf life. And since we are using hurdle technology, and we have seen their like shelf life evaluation, so they have mentioned like 4 to 5 months. So we are also aiming for that, and like since we have not developed any prototype, so we are also assuming like 4 to 5 months based on the scientific literature published on plant-based protein.
I asked this question for another reason, because the price was somehow hurting me, because when I look at the raw materials or the ingredients, if I'm going to just buy 1 kg of each of what you had mentioned, ragi or wheat and potato, that's all together going to cost me less than the price that you had projected in the product profile, So do you have any comments on that?
Yeah, definitely. Like we have searched, so like for mung bean protein isolate, so they were like 450 to 500. But we have, since we are using this high pressure processing UV, so hurdle technology, so that is adding the cost more compared to our ingredients. But since we are aiming for like clean, label free, less additive, so I think this will give like more health benefit to the people. And one more thing, why we have chosen these 2 ingredients based on their like water absorption capacity, oil holding capacity, so that we will be less dependent on emulsifier addition. Because this mung bean protein is also being used for like egg alternative. So like this, we have thought in different papers, and we have added, and like and we have thought like this is like cereal protein, then pulse protein and vegetable protein. So since we know like any food material is like not self-complete, so they are deficient in something. So we are trying to club all these things And one more thing, like we have done ranking of our ingredient based on like a nutritional profile. So like carbohydrate, fat, and we have also checked for PDCA. So we have compared related to milk. And one more thing, like we have checked for glycemic index also. So this this potato protein, ragi protein, and munging, so they are in like low GI, like less than 40.
That's all right. Yeah.
Yeah.
Thanks. I think you have some more questions from
okay, thank
friends. Yeah, thank you.
Thank you, Dr. Narayan. Dr. Gurmeet, if you want to go next.
What's the next milestone that you want to hit, and how much do you need for that? What funding do you need for that?
Like to be honest, like we have projected that much amount, but we have to do a lot of work on economic part of view compared to like scientific research and paper. And our target is to deliver like whatever the commercial products are based, like plant-based milk are available, like soy-based, cashew nut and all things. So we are aiming lesser than that. So it is a big challenge for
that, to put a prototype. Is there a shorter milestone that you have in mind?
Yeah, we would definitely like to collaborate with some like research institute where we can develop our prototype. After developing the milk, like what is it, like whiteness index, then particle size, stability, shelf life thing. This is our like short nearest milestone we are trying to aim at.
Okay.
Thank you, Dr. Gurmeet. Dr. Ashutosh?
Yes. My question is the shelf life and technology part of it. Means they have simply said the hurdle technologies, but I doubt that hurdle technologies will lead to such a claim the shelf life, because until you do not have if we compare to the milk, say UHT kind of technologies are not there with Tetra Pak. So are you really sure about that? What technology you have chosen is the correct?
Like we have taken the data from the research paper only, from where they have developed some plant-based blend. So they have used this thing.
Okay. So, but your ingredients versus their ingredients, are you sure? Means high pressure is fine. One thing which you have mentioned, but anything other than that?
Yeah, we have found paper related to UV also on plant-based protein.
Okay, one last question from me, that regulatory point of view, you are aware that what can you label the product as a milk? If not,
No.
then where would you like to put it?
Exactly. So like FSSAI have recently launched this vegan logo to like avoid the misconception of like veg and non-veg, and like they have drafted like new regulation. It is already going on, like food product standard for vegan food to 2021. So it is still under the process. So we will, as per
No, not vegan. I am specifically, I am for the milk imitations.
Yeah, like as per like FSSAI, we can't label it as like milk, because they are including it in vegan food, like plant-based, like in imitation, dairy imitation, like this.
Fine. So that challenge you are aware of. That's all.
Yeah.
Thank you, Dr. Ashutosh. It doesn't seem like we have any more questions from the judges. So thank you, team Like Milk, for the presentation. For judges, please add your scores to row number 5 for Like Milk. Now we can quickly move to team number 10, the last but one team. The team name is Veg Delicious. The technology area is plant-based seafood. The product name is Aquatura. The tagline is nutrition with greens from the blue. Aquatura Delicious patty. The primary team member's name is Shakti Lalita Shri, and the additional team members are Shruti Kar and Shreyasi Kar. So Shakti is basically a PhD student in the field of cancer biology and has expertise in biotechnology as well as bioinformatics. Shruti is from Mumbai. She is a final year student in post-harvest technology with expertise in microbiology, and Shreyasi Kar is again from Mumbai, and she's doing her final year masters in fish breeding and genetics and has expertise in nanotechnology. So their passion is to develop a sustainable alternative seafood system united which basically united the three of them to form this team and pitch the presentation as Veg Delicious. So over to Veg Delicious.
Good evening, all. I'm Shakti Laitashi. Together with me, we have Shayasi and Saushruti behind the team Veg Delicious. We are from a diversified background with expertise in various areas like biotechnology, microbiology, nanotechnology, informatics, and genetics. Our passion towards seafood and in developing a sustainable alternative food system brought us together into the ISPIC Challenge 2021. We belong to Track 1 and our main focus is to develop a plant-based seafood by using functional algae and fractionating their proteins and lipids into a suitable form. The global population is expected to reach 10 billion by 2015, which will lead to a 70% increase in food production. Also, the global demand for seafood is expected to increase by 30%. But how do we meet this demand? The seafood is mainly depending on aquaculture and wild captures. While the aquaculture can account only for 17 countries' demand and the remaining 170 countries are unmet. So how do we solve this problem? So that leads to the emergence of the alternative protein industry, which overcomes certain concerns like the bycatch, overfishing, the greenhouse gas emissions, and the habitat damage, which are generally done by the aquaculturing and wild captures. To account for that, our preliminary statistics prove that the global plant-based seafood market is projected to skyrocket with a compounded annual growth rate of approximately 28% in the next 10 years, with an valuation of 1.3 billion US dollars. Also, it shows that an increase to 1.4% dollar share of the US seafood market gives an 221 million US dollar opportunity in the market. But the alternative protein market also have some key challenges like matching the sensory experience of their conventional counterparts, matching the texture, taste, and aroma of the product, and also meeting the nutritional profiles. One solution we have for the seafood is the sea vegetables, that is using seaweeds and microalgae as a replacement, which can give both the sensory and nutritional profiles. So our main objective is to fractionate the essential nutrients from the red seaweed species Gracilaria edulis using some novel approaches, and also to develop an alternative highly nutritious and sustainable food product matching the texture, flavor, and aroma of the natural seafood. The rationale of our approach is that it reduces the environmental pressure. It also helps in scaling up the production process, which in general time consuming and economically not feasible. But with our novel approaches, we can do it with low investment by increasing the functionality of the products, which significantly saves energy and also gives positive environmental impacts. With our novel approaches, we can also do selective extraction of nutritional intracellular components, thereby increasing the product purity and quality. So basically, our experimental design is harvesting and cultivation of the Gracilaria edulis species using a floating rake method, following a biomass drying using ultrasound assisted freeze drying method. Then we do a selective release of intracellular components using a pulse electric field method, which is highly advantageous than high pressure homogenizer, where it damages our protein products. And we also defat our components by separating lipids using supercritical fluid extraction method with CO2 as the supercritical fluid, and we do a protein isolation by an alkaline extraction method following by centrifugation and ultrafiltration. Our end product is formulated by mincing banana blossom in the presence of lime juice to mask the bitter flavor of banana blossom. And we also add the ingredients like chickpea flour, herbs and spices, and our isolated algal proteins in appropriate proportions to blend and shape using a twin screw extruder, where our product is finally frozen at minus 40 degrees Celsius and packed to extend its shelf life. This slide gives the nutritional information of the three important ingredients we use in our product: the banana blossom for the flaky texture, the chickpea for increasing the binding ability and also add nutritional value to our product, and our red seaweed Gracilaria edulis, which gives the flavor and aroma to our product. When we compare our product to the competitors in the market, it stands out as we have no additives, no allergens, and we use a very minimal ingredients, thereby doing a minimal processing, which also decreases our time consumption, and we can offer our product at a lower price rate. So our budget is basically given in two scales, the lab scale level and the industry scale level, with an overhead of 20% and a margin of 15%. Our lab scale budget is estimated for 100 units, which on successful experimentation can be extrapolated into a larger scale. So our timeline to develop a minimal valuable product is basically 2 years, where in our first year we do the concept development, the system design, the complete design, detailed designing, the testing and validation of the product. In the second year, we do the mass production and the evaluation, following by which we do the go-to-market plans and branding of our product. Our SWOT analysis shows that our strength is basically we have a clear conceptual design with novel and feasible approaches, but the weakness maybe right now we don't have an experimental evidence for the product proposed, and our opportunity is that we have entrepreneurship opportunities. We can bring about a change in industry and also do a business collaboration, and our threats might be maybe we might fail to meet the customer needs or expectations. The cost and scheduling requirements may change. These are our supporting literatures. Thank you for the opportunity.
Yeah, thank you, Team Celicious. We can quickly jump into questions. So judges, please feel free to ask your questions. Dr. Gurmeet, please. Dr. Gurmeet, you're on mute if you're talking.
Sorry again. Yeah, good presentation, Shakti. I like that you had costing both at the lab scale and the pilot scale, and you had timelines. I couldn't get a chance to go through them, so I will not comment on it, except that things were very clear in your presentation, so good. My one question was just intrigued by your formulation, banana flowers and acid. So what are you trying to achieve by doing that? You have some personal experience of getting a seafood kind of taste by using that formulation?
Actually, seafood not yet, sir, but because I don't have that algal protein isolation right now in any experimental base. But personally, except for that flavor, I have arrived at the texture by just experimenting at home, actually. So I'm right now able to get that fish-like patty texture, but yet to do with the flavor and aroma.
And why do you take banana flower and lime juice and acid? Any particular reason for that?
Yeah, I would like to add.
Basically, banana. Yeah.
So Shruti.
Yeah. Banana blossom is very cheap. The cost is around 25 per piece, and it has also mainly contain huge amount of nutrients like low fat. Actually, it has low fat and high calorie, and it is low in cholesterol. So it is good, and also it is rich in vitamin E and other. So we have choose that banana blossom, and lime juice mainly. If any fat oxidation takes place here, this lime juice mainly reduce that oxidation, and also we can add vitamin C in our final product. For that, we have choose that lime juice, because generally seafood has no vitamin C, so it will help to increase that vitamin C content.
It's an interesting formulation. I haven't tasted, but my only experience with banana flower, since I have a tree growing in my garden, is that it is a little astringent. So maybe you'll just have to look at astringent beets. Yeah. But anyways.
I just want to add one point. Banana blossom is fibrous in texture, so it can withstand a lot of seasoning process also, and it has a neutral flavor. So
Yes.
it can easily adapt any kind of flavor. That's the main point here.
Okay, great. Thanks.
Thank you. Dr. Vasuman, please go ahead.
Thank you. Thank you for your presentation. I think for the formulation, I just want to double check. For the banana blossom, are you planning to add it as powder form before you going through the extrusion?
No, we are using the banana blossom in the raw form, actually. So we peel it off and we just mince the banana blossom in the presence of lime juice. so we get that flaky texture. We cannot make it as a powder. It should be the natural raw one.
Right.
To get
okay. So because I wasn't sure if you actually use as like a raw material and you subject it through the extrusion, what's gonna happen to your final product. So because usually with the extrusion process, I'm not sure whether going through that process, what's gonna happen to the structure that your banana blossom already have. That's all that I was curious about. So something to look into, whether you're gonna incorporate it before or after extrusion for the texture, because itself already have the texture, right? So necessarily it doesn't have to go through texturization as per your other ingredients. Yeah. And just a second question, for your extraction of the protein from seaweed, there's a lot of process which can add a lot of cost. So I was just wondering, is it going to be more financially feasible if you actually purchase that as a powder compared to extract it yourself?
Yeah, actually, right now we don't have a powdered form of that particular red seaweed we are targeting, but we are trying to adapt it in both the ways. If possible, if we can get it naturally as a powder, we'll incorporate it directly. If not, we are trying to extract it. That based on our experimental setup, we were thinking to change the adaptation.
Okay, understood. Thank you.
Thank you.
Thank you.
Iris, I think you have a question.
Yes, just quickly. Thanks a lot for the presentation. So I actually have two questions. The first one would relate to the macroalgae or the red seaweed. And it's about the scale up of the cultivation or production of biomass, how you plan doing it, because what I experience is it's not so easy to scale up macroalgae cultivation in a very homogeneous and constant way. So it's always fluctuating. So you could have shifts in production. So how do you want to cope with this? And the second question relates also to the extrusion. Which structure are you aiming for? And mostly you need a lot of protein or some protein source for giving structure to the extrusion. So how do you plan on doing this?
Yeah, so actually, once our lab scale experimentation is successful, then we can look for partnership and growth and investor for investment to the large scale. So if we achieve this, then we can go for mass scaling for production and commercialization. And first, we can go for Indian market in the local supermarket, and also we can have in street food restaurant for this product, and also among the flexitarians who love to eat seafood and all.
So what I would like to explain here is for the seaweed, like harvesting and cultivation is one point, but we are also trying in another way, like approaching the seaweed banks. Actually, we have some seaweed banks in India where we can directly approach the local people, like who are involved in fisheries and everything, and we can buy from them actually the dry seaweed. So one approach is like that. So instead of doing it, since it will cost more in harvesting and cultivation, we can choose that as an option also. So we can approach the Department of Fisheries here in India, and also like the local seaweed banks. For every state, we have the coastal states. So we can approach them for
actually,
that.
Being a fishery student, I think
Team Vegelicious, please close your answer very fast. If you have anything to say, please close in 2 sentences. We are running out of time. We have one last team to go. Thank you. Please go ahead, Tracy. If you want to say something, please go ahead.
Being a fishery student, I want to say that the floating rake method is the most easiest process for harvesting. It can harvest within 6 to 8 months.
Okay,
thanks.
Thank you, Iris.
Thank
you, team Vegelicious. Coming to the last team, the last pitch of the day, quite exciting. We have Team Protyllium with us. Team Protyllium's focus is fermentation-derived protein and ingredients. The product is Protyllium Foods. The tagline is leveraging microbial fermentation to feed the future. The team lead is Arman Dhanda, and the additional team members are Darul Islam and Shivani Vohra. Team a brief explanation about the team. Team Frutalium involves Arman Dhanda. He's a first-year undergraduate student at St. Stephen's College studying chemistry. He's a very science-driven individual and with an interest in business and entrepreneurship. Darul Islam is currently working with the government of West Bengal and has expertise in scientific and regulatory affairs related to food. Shivani Vohra is a graduate of biotechnology from South Asian University and has great problem-solving skills. So presenting to you the last team of Track 1 Demo Day Frutalium.
Greetings everyone, I'm Arman and I will be presenting on behalf of Frutalium Foods. We are leveraging microbial fermentation to feed the future through strain improvements in fungi. What comes into your mind when you think of crustaceans? It might be seafood, or shells, or even Mr. Krabs from SpongeBob SquarePants. But the most common answer I received was crab sticks. You may ask what crab sticks are. They're a type of seafood that has been shaped to resemble the leg meat of snow crab. It is only natural to assume it consists of actual crab meat, but that is honestly not the case. The reality of crab sticks is very concerning. They're made using bycatch pulverized fish, adding to illegal fishing and increased depletion of seafood stocks. It is very surprising that more than 60% of calories are from starch and not protein. Lastly, it is highly processed and is high in MSG and sodium. In fact, it is a golden example of repurposing a low-cost substance into something exclusive, very similar to synthetic leather marketed as vegan leather. It is startling to note that 80 to 90% of mercury in the human body is the result of seafood consumption. A recent survey by GFI indicated that it was the leading reason for apprehension against increasing seafood consumption. Most seafood you and I consume is either illegal or is intentionally mislabeled for increased profits. Our solution at Frutalium Foods is very simple. We have devised a strain improvement in edible fungi using protoplast fusion of lion's mane mushroom and paddy straw mushroom, scientifically called Hericium erinaceus and Volvariella volvaceae respectively. Our aim is to replicate the medicinal, nutritional, and organoleptic properties of H. erinaceus into the fast growth, thermolability, and ease of growth of V. volvacea. Lion's mane mushroom in itself is an excellent strain, but owing to a long harvesting cycle, it is sold at prices higher than 16,000 rupees a kg, while paddy straw mushroom is sold at 100 rupees a kg. Our goal is to devise a strain that has the most desired properties and can be harvested at low costs. Coming to the scientific design, you might wonder why we plan to use a protease deficient strain. H. erinaceus is low in protein, around 9.5%, and a research paper by scientists working at Quan, the leader in biomass fermentation, recommends the strain to have at least 30% protein by biomass. We use random mutagenesis as it is equipment light and is regulatory compliant. We use chemofusion to perform protoplast fusion as it has shown success in previous experiments and is easy to moderate. Our scientific experimental design will be broadly divided into 4 steps. Step 1 will involve increased protein content in H. erinaceus. The level of protease expression in the mycelium is a possible reason for low protein content. We start with identifying the protease encoding gene sites in H. erinaceus using protease screening kits. We use random mutagenesis using X-rays to disrupt these gene sites. Alternatively, the use of a strong promoter will increase alpha-glucosidase, which is a common protease inhibitor. After culturing, the mycelium will be screened for high protein content. Step 2 will involve hybrid generation by protoplast fusion. The selected H. erinaceus cultures will undergo the process of protoplast fusion along with the Volvariella volvacea, which involves firstly, isolating and preparing the protoplast from fungal mycelia. Secondly, polyethylene glycol mediated protoplast fusion. And lastly, the hybrid protoplast will be cultivated on the intended substrate. Step 3 will involve screening the hybrid protoplast. The phylogenetic relation between the parent and the hybrid strains will be identified by PCR amplification, followed by sequencing. The nutritional content between the parent and hybrids will be compared using gas chromatography for fatty acids, BSA for protein analysis, HPLC-MS to measure vitamin B12 concentration, and lastly, PDCAS score will also be determined. The biological efficiency of the strains will be calculated on the basis of their growing conditions, and statistical analysis using ANOVA will determine the variation between the parent and the daughter strains. Lastly, the cultures having maximum desired traits will be selected for biomass fermentation based applications. From the safety and regulatory lens, the strain employs non GM technologies. Toxicological screening under the Food Safety and Standard Acts and approval under the novel food category will be a requirement. The quality and safety of the fusion strain will be determined by an external lab accredited by NABL. Being thermolabile, the strain can bypass the use of expensive bioreactors and can grow on plates. Possessing natural bitter blockers, the end product will be clean label. The strain has medicinal properties which are nephro, neuro, and hepatoprotective and have shown to increase memory. The mycelia can be grown in days as compared to, let's say, weeks for plants and years for animal protein. Thus, economies of scale can be achieved easily. Lastly, it is a great source of vitamin B12, which is primarily found in animal protein. Government inclusion through social entrepreneurship programs can help in feeding the 190 million malnourished Indians and can be an excellent, low cost, high quality protein source, thus bridging the protein divide faced by the nation. It can alleviate poverty by being a recurring source of income for the farmer, as it is low tech, can be grown on any lignocellulosic biomass, and has a short harvesting time of days as compared to months for plants. It will simultaneously also reduce crop burning, thereby limiting air pollution. For industrial applications, the strain can be applied in three broad categories. The first is the whole cut crustacean alternative. The second is a hybrid product involving cell based and plant based proteins. And the last is a powdered version which can be used as a B2B product to provide a seafood taste and impart medicinal properties. For whole cut alternatives, innovation in the field of cultivation parameters is a necessity. As the strain can be used in both ground and whole cut alternatives, it is a versatile product. As fermentation is a tried and tested process, economies of scale can be achieved with ease. Moreover, mycelium based alternatives are less capital intensive and have a faster path to market, while having a benign carbon footprint. Cell based alternatives are very capital intensive, and plant based alternatives are highly processed and less bioavailable. Thank you so much for your time. Our team involves me, Armand Handa, a first year undergraduate student at St. Stephen's College studying chemistry. I eventually hope to change the future of food and see myself as an entrepreneur in this sector. I bring a Gen Z perspective to the all protein sector. Davrul Islam is currently working with the government of West Bengal and has expertise in scientific and regulatory affairs related to food. Shivani Vora is a graduate in biotechnology from South Asian University and possesses an analytical mind with problem solving skills. We would thank you for patiently listening to us. And if you would like to know more about us or potentially collaborate, do reach out. Thank you so much.
Thank you. Thank you, Team Prudarium. Now the floor is open to questions. I see one raised hand, Dr. Gurmeet, please go ahead with the question.
Delightful presentation, really good. Enjoyed it. Question, how long do you think you will take to up the protein levels? What kind of facilities do you require? Where will you do the work? And how much of money do you think you'll need for that?
Great question, sir. Those are actually the things that the issues that we are currently facing. And in my opinion, Shivani Vora, my team member, she would be better able to answer the question because she actually has experience in the lab.
Okay. Shivani.
Yes. So for asking about increasing the protein content, so as we have already bioinformatically seen, like I have checked for different databases for if the genome for RNA already code for any protease. So there are very less documents that see that it has a protease in it. So it's very easy, like it won't take much long time. It may be as we approximate at we can, for increasing the protein content, we can first go for protease identification. If that's not, then we might change for optimizing their growing conditions for better protein expression. So that may take around I think 3 to 4 months. That won't be a big deal.
And so in terms of the equipment, if we can, let's say, refer to similar research that has been conducted for oyster mushroom and for straw mushroom, I have the list right in front of me. I can probably read it out. So the equipment that they required was a hemocytometer, a gel electrophoresis machine, some
Fine.
lysozyme.
I'm guessing
Yeah.
you've done your research. Just wanted to know if you have identified a place where you will do this work, or you have to do that next step.
We are still looking for facilities, but sir, the most viable option, at least according to our research, is DMR Solon, because that's the leader in mushroom-based research. That is one possible solution, but we're still on the outlook for potential sites to conduct the research.
And will this be a new food from a regulatory perspective? Any thoughts on that?
Yes, sir. Yeah. It will be a novel strain, but we also have an alternate path. Let's say what we are proposing does not end up working. Our backup solution is to provide the correct environment for the lion's mane mushroom to proliferate. So currently it takes about a year for the mushroom to grow. And if we actually haven't done the in-depth research on it, but we propose that if we're able to find the correct environment for its growth, we can reduce the harvesting time.
No, I was checking the regulatory perspective. If you have
actually, that will come under the novel food category. We'll have to get an approval from the FSSAI.
Okay. You have to build that into the time, but that's for future, right? When you go to commercialize.
Yes, sir. Yes, sir.
Good, thanks.
Thank you, Dr. Gurmeet. Any more questions from judges? We have a couple of minutes soon after which I'll close the session. So please go ahead with your questions. If anyone has, please unmute yourself. Thank you.
The team name was, sorry, I'm missing the team name.
Protelium.
Protelium, thanks, yeah.
Okay, seems like we don't have any more questions for Team Protelium. And so I think we can close this session. Thank you, teams, for presenting your pitches and actively participating in your respective Q&A sessions. I personally enjoyed all presentations, and we hope that all attendees also thoroughly enjoyed listening to new ideas and potential innovations that our young scientific and business minds have brought to the table today. TrackOne focuses on coming up with innovative theoretical solutions to a technologically advanced scientific problem faced by Indian food corporations, startups, and entrepreneurs. The top winners will be announced soon and will be eligible for a combined prize pool of 20 lakh rupees INR. The Indian smart protein ecosystem is just picking up. Plant-based proteins, and just picking up, especially the plant-based protein side of things, and it's still very nascent in terms of cultivated meat and fermentation. Hence, challenges like ISPIC 2021 are key to bringing technical and fundamental solutions to the table, which focus both on local as well as international global markets. And there is an urgent need to build talent, right? So, and a thriving research ecosystem in India to keep up pace and growth as compared with the global peers, as the smart protein sector is seeing rapid growth and investments year on year across the globe. So we once again thank our judges for their commitment and their precious time. Dr. Madhusudan Rao, Mr. Rakesh Rajiv, Dr. Narayanan, Dr. Ashutosh Upadhyay, Dr. Vasavan Nutakul, Dr. Gurmeet Singh, and Dr. Iris Habakon for your time and your patience. And we will be sharing the results, post-event analytics, and the impact of ISPIC 2021 in the coming weeks with you all. With this, I wish everyone a great evening and a happy weekend ahead. Thank you.